Welcome to the SMART Extrusion Conference. This is the first day of Taiwan SMART Agriweek here in Taipei, and our SMART Extrusion Conference is being held for a third time here at the conference, at the exhibition. My name is Roger Gilbert. I'm the publisher of International Aquafeed and Fish Farming Technology magazines, and we are organizing this event along with Dr. Mian Riaz. Dr. Riaz is a Pakistani-American food scientist, an academic, and author. He is a professor of food diversity and director of Extrusion Technology Program and the associated department head for food science and technology at Texas A&M University. Dr. Riaz is authored and co-authored research articles and has written several books on the subject. And he has received several awards for his work over 33 years, I believe, Dr. Riaz, at Texas A&M University. He's the recipient of the 2016 University of Maine Bernard Lawn Alumni Humanitarian Award, the 2023 International Food Security Award from the Institute of Food Technologies, and the 2023 Texas A&M University Dean's Outstanding Achievement Award for International Impact. He is a frequent speaker at conferences, and we are very pleased to have him here today. Thank you very much, Dr. Mian. Riaz, the floor is yours. Thank you.
How many of you work with extruders? Can you raise your hand who work with extruders? Nobody work with extruders? Anybody know what extruder look like? Okay. You are all here to learn about extrusion, but you never seen extruders, anything like that? Are you seen extruder?
You have to do your intro again.
As you can, you tell it's interactive, right, Roger?
Yeah.
Okay, well, I know language is always the issue. First of all, thank you very much, Roger, for the invitation and for the introduction. I'm very happy to see that you guys are here to learn about extrusion. Therefore, hopefully, it's your chance to ask the question. It's your chance to interact, so you can learn about extrusion. This is the agenda here. As Roger mentioned there, you will see that one here, agenda. I have multiple talks. First talk, and then maybe we can take quick 2-3 minutes stretch break, and then we go to the second talk, the third talk, and the fourth. Therefore, you're going to hear a lot from me today. And basically, I'm here for you. I just pay especially from USA. Therefore, if you do have any question, do not shy. Do not be hesitant to ask the question. We will have a question answer session maybe after every presentation. Therefore, the very first presentation is called how you engineer the pallet, which is a perfect feed. And for that, we have to use and choose better extruders that can make it Aquafeed and pet food. I don't know how many are you here making Aquafeed, how many are you making for pet food, or how many are you going to make both product. But basically what I'm going to give a talk here is going to be discuss about Aquafeed as well as pet food, because extruder don't know you're making Aquafeed or pet food. Basically, as soon as you change the dye, put the raw materials, they're going to make a pet food, they're going to make Aquafeed. But just to give you some background here, if you look at early time, this is the way that they used to make it Aquafeed. I was in Bangladesh 20 years ago, and I saw that one. They have meat grinders, and they were grinding, putting the raw materials in it and making the Aquafeed there. And the people also make it like small Aquafeed at home as well. But what we're going to talk about, as Roger mentioned, AI and all the latest technology we have into making an Aquafeed, and that's what our goal is going to be today. Then how do you choose an extruder? What are the requirements? How do you know which one I needed? There are hundreds of manufacturers, okay? And they will make you confused. There are so many different routes that you can go there, but there's no any straight route. Because I see that there's a lot of people here in Taiwan, in other countries, neighboring country, India, China, and then of course Europe and USA, everybody making extruder, for making it for Aquafeed, for the pet food, and everybody think they are the best. And of course, Everybody have to sell their machine, therefore they are the best for them. But what do you need? How do you know which one do I need if I'm making a pet food or Aquafeed? What is my goal? How do I need that one? Therefore, usually, I've been here for A&M for a long time, and I got a call once in a month from somebody, Dr. Riaz, we want to buy an extruder. Which one do you recommend? I tell them I don't recommend anything. I ask these questions because I don't endorse anybody, but I ask them what kind of product you want to make it, how much is your feed rate is going to be, marketing going to be, your recovery period, your maintenance cost, what is your operating cost, what desired product you want to make it. Then once you know everything, you want to make Aquafeed, you want to make a pet food, you want to make a both, you want to make a simple aquatic feed, a simple pet food, or you want to make a multiple pet food, different shape, different design. And based upon that, you will select an extruder. It's not that easy because it's almost more than $1 million investment. Therefore, you need to understand what are my needs are. How do I pick something which is best for me? Therefore, to understand that, what we do here is that we look at typical extruder and then see what is best for you, what things you think you will work for you. Therefore, to understand that, a typical extruder, we have 4 different areas. We can divide them. We will have some kind of feeding system, some kind of preconditioning system, some kind of, again, barrel, the heart of the machine, and then this is the knife cutting device. Therefore, this is the machine. If you've never seen it, you can divide them into 4 areas and see which one do I need it. Do I need a preconditioner? Do I need what kind of feeder do I need it? What kind of barrel do I need? A single, twin? We will discuss that all. That will fulfill your need. Therefore, basically, the function here is, again, this is the delivery system, this is the preconditioning system, this is actually extrusion, and then we have a shaping and cutting here right there on the end. Therefore, let's talk about first a delivery system. What's the function of the delivery system? It is mean if we have to uniformly deliver the raw materials to the next step, uniformly. And therefore, there are different kind of delivery system. We have volumetric and gravimetric. What kind of do I need it? Volumetric going to give you a volume. If you want to make a one product, Aquafeed or pet food, that's the best. Easy, simple. But if you want to make multiple recipes, you want to change your recipe density all the times, you want very, very accurate, you may want to think about volumetric, gravimetric, or loss in weight. Therefore, if you look over there, that manual, or we call it volumetric, is very simple. You just have a knob and you will turn on, I need 10 RPM, 15 RPM, 20 RPM, and you're going to get the raw material. But what's going to happen? When you change your recipe, your density will change. Therefore, this volume is going to give you more raw material when your density is heavy. When the density is light, you may get less raw material. Same is true for that when the bin is full, it's more pressure on it. Therefore, you are going to get more delivery system. If that affect your business, that affect your finished product, then you may want to think about loss in weight. Loss in weight basically is a little more complicated, more advanced, and it has a scale on it, load cell. You stay on there, therefore basically it will give you 5 tons per hour. You change your recipe, who cares? You change your bin is half, who cares? It will give you exactly, because it's going to weigh it, but it's going to give that one. But again, this choice comes with extra tools, extra equipment. You are going to have this extra surge bin, then you have slide gates, and then of course you have actual live bins here. So you have extra part there. Therefore you compare that one, volumetric, gravimetric. Volumetric is that where you set up the feeder speed. Here you basically have a system control that feed rate affected by bulk density, no effect here. Simple mechanical design, more complicated, low cost, more cost, no requirement to bin to fill rate. Here you have to fill that extra 30 minutes. Therefore, going back to you is what you need. Are you going to make a multiple recipes which has a different density, light density, heavy density? You may want to think this one. You're going to make a multiple kind of fish feeds that you are changing all the times and all that. You really don't care, just have one type. Maybe volumetric is much, much cheaper for you. Just buy that one. Whereas if you want a gravimetric, or you want a loss in weight, you want to be very accurate, raw materials comes in, you have multiple recipe, then think about loss in weight, because that can cost you more money and also maintenance. Therefore, that's the first thing you need to think about your delivery system. Next, go to the preconditioning system. What's the function of the preconditioning system? First of all, do I even need a preconditioning? For making full-fat soy, we don't need a preconditioning. For some of the other products, we don't need a preconditioning. We always need a preconditioning when we have more than 18% moisture content in the recipe. In Aquafeed and pet food, we have more than 18% moisture. Therefore, preconditioning play a very, very, very important role in the pet food and Aquafeed. What's the function of preconditioner? Three main functions. Number one, it hydrates the raw material. Number two, it heats the raw material. Number three, you can mix your fresh wet material with the dry material. Pet food, we add a lot of fresh meat. We want 100% fresh meat into that, your recipe, and it will mix it. In the fish feed, we add fish slurry. If any liquid comes in, you can mix that one also. Therefore, remember that three main functions of the preconditioning: hydrate, heat, and mix dry and wet. Therefore, basically, it's the unit that is just before the extruder, which will basically pre-mix the raw material. Now, what is my choice? Again, like feeding, there was only two kinds of feeders, volumetric, gravimetric. Preconditioning, there are 7, 8 different kinds. Number one, you will see that we have a called single preconditioner. That means just one shaft. Okay, it's very simple to operate, limited ability to mix, to hydrate, to gelatinize the starches. Then we have a double conditioner. Of course, you have two shafts, better mixing, better hydration, more cooking. Therefore, you keep going up. You buy the car, very simple car, from Suzuki to Honda to Toyota to Corolla to Mercedes, you keep buying it. Then you have it also DDC preconditioner, that is differential diameter. That means it has a basically two shaft, one run faster and other one run slower. This is a smaller one. That is mixing, this is retention time, and it gives you much better cook. Then you also have, some people will sell you 2 stages preconditioner, depending upon your design and all that. You can have a dual preconditioner, which is one same concept, which is one on the top, that will be high speed, and this low speed mixing it, and you will have that as well. Therefore, you will see that comparison wise, the single is going to give you 50-second retention time, this much starch cook, you get much better starch cook, more retention time, and then around 50% starch cook, and then got 80 retention time. Why is it important starch cook? You don't want to feed uncooked starch to your dog and the fish. We have to fully cook the starch. Therefore, basically, if you have not fully cooked pet food, your dog is going to have loose motion. And the complaint customer is going to say, I feed your pet food and my dog have loose motion. The fish, they're going to throw out, and you have also all the feed and the water coming up there. Therefore, if you want to do the experiment, today when you go home, you are baking bread at home with the starch, with the flour, don't cook full bread. Cook a half starch and then eat it to see what happened to yourself, stomach. Same thing happened to the animals. You don't want to give them uncooked starch. You want to give them fully cooked starch. And this is where you play an important role. Therefore, different manufacturers sell different wings. This one has other system where you have a steam and liquid comes here in that raw material in this one unit. Again, same high speed and retention time. And then of course, therefore there are different kind of preconditioner that are available to you depending upon what you need are. Lately, people want to add fresh meat. In US, we add 100% fresh meat into our dog food, for premium pet food. For that, you need a unique design. For that one, you have to have a high intensity preconditioner. This has 2 motors. Okay, one runs clockwise, other run anti-clockwise. One you can run high RPM, other you can run slow RPM. And you can have as much retention time you want, up to 5 minutes, and very good mixing. Therefore, if you want to make a pet food and you want to add fresh meat, you have to use this kind of preconditioner. Then also, if you want to make a new technology, the shrimp feed. You're using extruder now, making a fish feed or sinking a shrimp feed. You may want to look into the high shear preconditioner. And this one here is this kind of preconditioner, which basically have a very good compression ratio. It decreases the volume, reduces all your air from the material out, compress the material, so materials go and extrude. When you go, it's go to the bottom, it's sink all the times. Therefore, now I give you 5 choices of preconditioner. Which one do you need? Depending upon your needs. Do you want to make a pet food high protein, high moisture meat? Then also making shrimp feed, sinking, floating. You want to have it very simple, just buy a single shaft preconditioner. Therefore, remember that these are the 5 different or 6 different kind of preconditioner that you can choose there. Next, we have to go to that barrel. Which barrel do I need it? Most of the time people think I have a single shaft and double shaft. When do you need a single shaft, when you need a double shaft? Basically, it is depending upon your need, and we will discuss that one here after that. And then of course, here is the die that comes in. What kind of die design do I need it? Therefore, just to give you an idea what happened into the extruder, and just to give you that how it works, just I have this small animation, and you can see that how it's going to work. Basically, you have some kind of feeding system that you feed there. Therefore, your raw material is going to come here in the feeder, and it's going to feed the raw material very uniformly. This is the function of the feeder. Then it's going to come to preconditioner, and that's where you will mix your steam and your water and your fresh meat and your fish slurry, everything in it. And from here, material will stay there 30 seconds, 40 seconds, 1 minute, 2 minutes, 3 minutes, 4 minutes, depending upon your requirement. Then it comes to the barrel right here, and then of course you will extrude here. Then this is the die that you basically will cut the product. Therefore, what kind of shaft, single screw I needed or double screw I needed? What's the difference between single and twin screw? The single one have a same delivery system as twin, same preconditioning system as twin. The only difference here is it has one shaft like that one. Okay, that's why it's called a single shaft. And it application wise, its capacity is very high. You can go to 20 metric tons per hour. You can run a different RPM, have a very big length to diameter ratio. You can have variable speed. You have groove barrels, segmented screw, steam lock. These are all the options. You will get that one. And mostly, where you use them high energy pet food, expanded pet food, floating aquatic feed, sinking feed, and maybe making full fat soya. That's what it is that comes in. No, they comes in different shapes and different varieties. For example, the very first one is called segmented. That means you have different segment of that each of the parts of the barrel. So you can design yourself to make it one day floating feed, other day sinking feed, one day making pet food, other day making some other full fat soya. Therefore, when I say segmented and jacketed, what I mean here is that these are the screw which is segment, okay, and then there's a jacket on, and then these are the barrel, and then offside there's a jacket in it that you can preheat the barrel. Therefore, basically it gives you option if you want a segmented and jacketed. That means you can make it floating or sinking. You can design yourself your different configuration. This will be for the sinking feed, this will be for the floating feed, but you can have an option to do that one. But it costs you more money. But there are a lot of single screw extruder. They are just basically one shaft like that. These are not segmented. These are not jacketed at all. Therefore, it's very simple, costs you less. If you want to make it only one product, this may be your choice. Then also we have called interrupted flight screw barrel. This is the shaft, this is the barrel. That is, before it has a pin in it. The pin will mix with the material with this kind of product, create a lot of aggressive environment in it, cook it, and then basically you will make the product. And this one is not segmented, not jacketed. You basically have your feed comes in, your water comes in, your steam comes in right in the barrel, and then you, of course, you go from here. This is a very simple one that you can have it less expensive, but also limited capacity. And this will one you see there. This is the feeding one, this is your magnet, and then it go like that. It's a very, very simple machine. You can also look into it, what kind of product you want to make it. Because you can design them low shear machine, single barrel, medium shear, and high shear. Therefore, these are some of the properties that you will get there. And then what kind of product do I make with them? With that low shear, I can only make a pasta, confectionery, soft treat, maybe pet treats, dense form. Medium one, pet food, aquatic feed, livestock feed, moderate expansion. And the high shear is going to be breakfast, cereal, snack, TVP, and highly expanded product. Therefore, depending upon what is your category, which is mostly medium shear, while making pet food, aquatic feed, you want to buy that kind of extruder. Then, we also have a single shaft, which is called dry extruder. What that means? Dry extruder means it cook the material by friction only. You do not inject any steam. 100% cooking done by friction. There's no any other source. And this is the one which will basically, you put the feed here, and sometimes they come without preconditioner, and then here you can also just sometimes you have option a little bit of water, but basically cooking will be done with very big horsepower motor here. All the friction, there's knife here, and you can make aquatic feed and pet food. They also come segmented, but not jacketed. There's no jacket on it. You cannot heat the barrel, but this are basically is that segmented, so you can change it to make it full fat soya, aquatic feed, and pet food. And then also they come with a preconditioner. Therefore, you can add a preconditioner on the top of that as well to increase your capacity. Therefore, basically is that it's a high shear, but you can also get it with a preconditioner. Then you go into the twin screw extruder. Okay, they're more sophisticated. Same delivery system, same preconditioning system. The only difference is going to be here, you have two shafts, and that make it more flexible. When you want twin screw, then you want to make it, first of all, your capacity is going to be around 60 metric tons, few RPM, length to diameter ratio, you can see a variable speed, smooth barrel, segmented screws, and self-wiping. And that is when you use this one, and most of the product, you can make it here, high energy pet food, expanded pet food treats, floating aquatic feed, sinking, full fat soya, very small aquatic feed, and very high fat content like salmon feed, that all can be done with the twin screw extruder. And they are also segmented and jacketed. Segmented means they have different screws there, and jacket on it to heat that barrel. Therefore, you will find them most of the time. They are screws there that you put together yourself to making one kind of feed, and then you can also do that. And then some of that comes in twin screw without preconditioner. There's never have a preconditioner on it, and people use that one to make it also fish feed, also as pet food, but there's no preconditioner on it. They just use it, water directly in the barrel. That's the other option you have it. Then in that one, in the twin screw, you have intermesh co-rotating and intermesh counter-rotating. This is the one we use most of the time, but you can also have a counter-rotating, which is mostly used in other industry. You don't find them here in that pet food, aqua feed, mostly in confectionery industry. Mostly you see it, candy industry, that's where we use it. And that's where the different screws look like there. And you can see here, this is the counter-rotating screws, and this is most posting transportation, less mixing, high pressure if needed, less cook, more farming. If this is the one which is also being used. Therefore, I gave you a lot of different options, single and twin, and also give you in between single different option and twin different option. When we use that single or twin, basically, if you want to make it internal fat more than 17%, you have to use twin screw. When you make a salmon feed, 40% fat, internal fat, you have to use that one. And if a fresh meat more than 35%, you have to use that one. Uniform size and shape, maybe you have to use that one. Small sizes less than 1.5 millimeter, you have to use twin screw. Greater ingredient flexibility, frequent product, you are going to change over different recipe. Every day you changing the recipe. You have to change that one. And it's much easier because self-wiping that you can use twin screw extruder. Therefore, basically, if you can see here, the single has this much window, the twin has a little bigger window. Therefore, you have more mechanical energy, more you can add the fat in it, lipid, fibers, protein with the twin. But with the latest technology, with the AI, and also with the new things that this window is getting closer and closer. Therefore, there's only small gap is left here because of high, basically you will fear variable speed, computer control system, advanced dye technology, new design. Therefore, all that is making a single also very close to twin. But there are still some product you cannot make it with that twin, with that single. You must use twin. Therefore, all the product the single make it, twin can make it. All the product twin make it, single cannot make it. Okay. Then we also have a called new extruder called a thermal twin extruder. And thermal twin extruder is where you have different designs, same delivery system, same preconditioning, but it's more thermal cooking. That's when you want to go to more than 100%. You want 150% fresh meat. You don't want to cook any with a shear. You want to cook with a thermal energy. That's where it will come up. And you basically have a different design here with the barrel. And then that allow you to add more thermal energy. And that will give you basically more than 150% fresh meat into your dog food, pet food. Then we also have a called a conical screw like that. Compression ratio is called a twin screw extruder. This is not segmented. There are two screws, shaft, but they are different compression ratio. And then they are controlled by called a back pressure valve there. This is like tapered 3:1 ratio. Therefore, these are 3 times bigger screw on the inside than comes outside. And they are variable speed shaft, and you control the back pressure. So what is the benefit of that twin screw extruder? They are cheaper than the twin, more expensive than the single, it's in between. And also, screw life increase, because now we have one big shaft rather than have small pieces. You have one long shaft there. That's why it is much better. Initial cost is less, but also maintenance cost is less as well. And since one long screw, there's no configuration required. You don't have to change every time. You just keep using that same thing. And flexibility is limited, not the same. Therefore, just to summarize that one, if you can see here, you have a single screw extruder, you have a parallel twin screw extruder, and you have conical twin screw extruder. Your capital cost, your operating cost, ingredient flexibility, of course configuration changes or not, density control, system complexity, and of course turn down ratio, how quickly you can change over all these things. That is basically you have to compare yourself, what is my need? What do I need it? Do I need a single? Do I need a twin? Do I need a conical? Do I need a thermal? Do I need a segmented flight? Do I need a non-segmented flight? Do I need a jacketed? I need it without jacketed. What do I need it? The last thing is that we call it dies. There's also a lot of different options you have for the die. What kind of die do you need it? Most common die for aquatic feed is very simple die that we use it. These are mostly for the either use with the fish feed or dog food, whatever you need it. But lately we have also a different kind of dies that came up in the market that will increase your capacity. That's usually use this die design to making a fish shrimp feed. In this case, you have this is the function of the die from here to here, and this is basically have a 3 different outlet, and then 3 instead of 1, you have 3 different tubes, and it comes up from 1, 2, 3, and then this population is 3 times bigger than the normal one. Therefore, it will increase the cook, but decrease the expansion. If you want to make a shrimp feed, you want to make a sinking feed, that maybe you want to consider this kind of die on the end. And basically, it has a very uniform cross section, and you can see here, you have like multiple dies opening here in this case. Therefore, you can make a very, very nice, large scale, your shrimp feed or microaquatic feed with that one. Therefore, basically the benefit of this kind of die is that higher rate, more size uniformity, better product density control, much more sinking, and also increase the water stability. Therefore, basically you will see that one, this is what you have it. And therefore, going back there, the extruder option, we talk about it, you can have one kind of feeding system, which is all gravimetric, or you got a volumetric. Then you have option for preconditioning, single, double, differential diameter, high intensity, and high shear. Then you have a barrel there, conical barrel, regular barrels, a single screw or twin screw, and then of course different kind of die. Therefore, you have multiple option that is available to you in the future to pick what you needed, what your needs are, because it's expensive. Therefore, there are different options that you will see there. There's extruders that are making a shrimp feed. There are extruder as bulk one, which is making a floating feed. This is for small microaquatic feed. This is a thermal twin making a marine fish feed and all that. Therefore, you have different extruders available, different varieties available that you can pick whatever you needed for your need. Okay. And with that, I'm going to stop here. These are 3 books that I published. The very first one was from USA, Extruders in Food Application. This is from Germany, the Extruders and Expanders in Pet Food. And this one is from UK, Extrusion Problem Solved. I do have these 2 books here in case anybody want to see it. And if you want to buy, even though you can have it because it's a very heavy book and shipping is much more expensive than if I brought 2 books with me. I don't sell the book, by the way. This is my own personal book, therefore I just bought it here. With that, I'm opening the floor for question answer. Any questions? If you don't ask the question, then I will start asking the question. So anybody can tell me what kind of machine do you have it? What kind of extruder do you have, guys? Nobody have any extruder? And you don't want to talk? Okay, it's your choice. Thank you.
Just a couple of minutes, Mian.
Sure, if they want it.
Just take a couple of minutes while he prepares for his next.
Just 2 minutes, not more than 2 minutes.
Please be on your shirt.
Sure.
if you
Okay.
like, yeah.
Perfect. Then. You can take one or two pictures with mine too. Just push
Okay,
from
sure.
here and you'll turn on
Yeah.
the picture light. And when I give a talk, then you can. Okay, if there's no more questions, we're going to continue then. Second presentation is about the raw materials. What things you consider when you're selecting the raw materials for aquafeed or for pet food. Just to give you an idea that if you're making a pet food and you're making aquafeed, 80 to 85% cost is raw material. Therefore, you want to be very, very careful about your raw material because it's going to cost you a lot of money. And it is very, very expensive part of the pet food and also aquafeed because this is the most expensive. 80 to 85, sometimes 90% cost is the raw material cost. Therefore, how do you choose the raw material? First of all, every time you make a pet food or aquafeed, you have to consider 4 items. Number 1 is your raw material. And then, of course, what kind of machine do you need it? Then what kind of processing condition and what kind of product you want to make it. Therefore, if you want to make it floating fish feed, if you want to consider what your raw material is going to be, what is your configuration hardware is going to be, what is your processing condition going to be, and then, of course, you can pick that one. So how do you pick the raw materials? You pick the raw materials for the pet food, for all these things based upon your nutrition, based upon your processability, based upon your economics viability, uniformity, of course, how much you want to add that one, the fat into it, what kind of texture do you want it, what kind of palatability you want it, what kind of appearance do you want it. All that will depend upon raw material. Therefore, raw material is one of the most important parameter in the extruders, and that's going to give you some issues there if you are not careful, if you don't understand what that is. So what is a typical aquafeed or pet food formulation? We will have some kind of protein, we have some kind of starches, carbohydrate, some kind of fat. Therefore, we will discuss that, why these things are important in extrusion and what you need to consider that one. What's the function of the protein? Why we add them? 2 reasons. Number 1 is they provide nutrition to the pet food, nutrition to the aquafeed. And the second one is provide functionality to your palate. I'm not a nutritionist. I'm not going to discuss about nutrition. We will discuss about only the functionality of the raw materials, how good they are, how they are functional in your protein and all that. And this is where it's more important. And when I say functionality, what that means? That means that if you're using a functional protein, they are the one who are going to give you the color, the flavor, the texture, the smoothness, turbidity, solubility, gelling, water holding capacity, synersis, viscosity, emulsification, foaming, stabilization. List goes on after extrudability. Therefore, these are the functional property of the protein we're looking for when you make that pet food you make for aquafeed, because this is very important when the extruders. If your proteins are not functional, you will not be able to use it. Okay? Therefore, what are proteins? How much we use it? Depending upon your formulation, you can use it 25 to 70%. Several role other than nutrition, such as water absorption, elasticity, binding, and very important part of aquafeed as well as of the fish pet food. We have to use them all the times. What are the sources of protein in aquafeed and pet food? We have a plant proteins that usually have a soy, legumes, wheat, corn, gluten. They are good functional properties if they are processed correctly, relatively low cost, but you have to add some amino acid. And whereas we have a animal protein, in that case, they are poor functional property if processed incorrectly, relatively higher in cost, and good amino acid. You notice that I use the word poor functionality and I have used the word called a good functionality. What that means,
that how good they are going to be working the extruders, the protein wise. To just give you idea that when you have a functional protein, you add it into that native state. As soon as add in the preconditioner, adding the steam and the water, they will start folding up like that, swollen up, and then they will start unfolding it into that, and when you go to the dye, it will texturize it, therefore give you very nice palette, or they give you kibble. Therefore, if I mentioned that vegetable proteins are good only if they process correctly. If they don't process correctly, then it's not good. This is all soybean meal. Nutrition wise, they are 48%, but they process differently. One is processed very, very high temperature. They have 7 PDI, protein dispersibility index. It's going to be very dark color. It's not going to bind the palate very well. Whereas this one here is 50 PDI, 54. It's going to work very nicely in the extruder. But nutrition wise, they're all the same. Nutrition wise, they are 48% protein, but they were processed in the soybean plant differently. And then also you can create different characteristics. When I made that one is very sticky, one is very smooth, and one is in between. All 48% protein, but they were processed differently. One is very sticky, therefore it may not give you a good result in the extruder. Very sticky, and some of them are not sticky at all, but they are all 48% protein. This plant protein. Animal protein. How do you make the animal protein? Fish meal. Here's the example. You have a fresh meat, and you can make a very nice hamburger, like this kind of beef patties. Then if you cook this one first, and after cooking it, can you make that hamburger? No. Why not? Because we lost the functionality. How the fish meal is made, how the animal meal is made. They cook them very, very high temperature. They catch the fish, small from the oceans, and then up there they will cook them to get the oil out and give you the cooked material. They expect you to take that material and bind again. It's not going to bind properly. Therefore, unless you spray dry materials, you can have spray dry materials, a gently cooked material, they will work. But if you have already animal protein, there was very, very high temperature, was cooked already when making the fish meal, making that poultry meal, making that, meat meals, they have lost their functionality. No, you cannot bind it in the extruder, and extruder will not bind together. Therefore, you will not be able to make a very nice palette. And how do I know that one? You can take a very small beaker in your lab, and you can basically add one of your protein, and you can see this is it's a blood, spray dry blood. You can see how homogeneous is that one. That means it's very good. It's spray dried very gently. It will work very nicely. Whereas this one here is a ring dried blood meal, where you can see that it is basically right here on the top and on the bottom, and it's not mixing it very well. Therefore, this will not work in the extruder. Therefore, basically, this is the one which is going to work nicely in the extruder. Therefore, you can basically, when the protein comes into you, you can take it in the lab. And I visit a lot of facility, and I can see that a lot of, what happened here? You can see here, a lot of people having a hard time checking their functionality, and all the things like on the top, like just the bones on the top, and sometimes they have sand on the bottom, they will not work in the extruder. Therefore, my point here is there are different kind of proteins available to you, all different kind of protein. You have animal protein, you have plant protein, you have from the animal, you have spray dry blood, you have a fish meal, you have a bone meal, you have meat meal. Similarly, from that other side, you have a soybean meal, you have cottonseed meal, canola meals, all that kind of meals there. Understand the functionality. Understand how good they're going to work in the extruder or not. Because you can have $1 million extruder, but you're not able to make good pellet if the protein is not functional. You're not going to be able to make good quality of fish feed if they are not good quality, your animal protein or plant protein. Don't blame the extruder. It's your raw material is not functional. It's not working together. It's not binding because the raw material has already been cooked. And you don't know how they made the raw material. You never go see them. Have you ever gone to see your supplier, how they make the raw materials? Have you ever see the soybean plant, how they make it? Have you ever seen the fish feed plant, how they make the fish meal, bone meal? You just buy them, you order them, and they give you what they have it. It may be cooked very high temperature, may be cooked on different temperature and all that. One day you have this one day you have that one. Then second one is carbohydrate. We use that for also different sources. We have most common is that we have basically corn. You can see here we have wheat, rice, oat, barley, all that. Sorghum too. And also we have it In this part of the world, maybe we have some of the cassava, you have tapioca, and you have also yam and potatoes, all that. They're sources of starch. And we get the starch from them and we use them. What happened to the starch when you use it? What's the function of the starch when we use it? Number one, it's a source of energy. It gives you energy there in that dog food and fish feed and all that. Also, it helps you to expand. It's basically that expansion, give you a lot of expansion there. Also, it improves binding of the pellet. If your pellet is not binding, then it's going to bind the pellet very nicely. And the level is, you can depend upon your formulation. You can have 10 to 40% aquatic feed. Same is for the pet food, depending upon what your requirements are. And all the starches are different. They're going to behave differently. Some of them are long chain. They're called amylose, and some of them are amylopectin. Are the both starches are going to work in the extruder the same? Maybe not. And I will show you that why. Because this is just different starches, and you can see the amylose and amylopectin. Amylopectin have a lot of branches there. Therefore, extruder has to spend a lot of energy to cook that starch. Whereas amylose have one chain, it's going to come and slip like that very easily. Whereas amylopectin is going to give you more expansion, more cooking there, more give you that energy you have to spend there. Therefore, in extruder product, amylose will provide you some crispiness if you want for that. And of course, it will also, but not give you too much expansion. Whereas amylopectin will give you greater expansion. Therefore, depending upon if you want expansion, you may want to pick the starch which has more amylopectin. If you don't want expansion, you just want to make the product, you may want to look some starches which is amylose. Okay? And there are different sources there that's available to you depending upon your requirements are. What happened in the extruder? We cook the starch, we gelatinize the starch. What are the requirements to gelatinize the starch? We have to have a temperature, we have to have water, and we have to have a retention time. In the extruder, we give retention time in the preconditioner, we add the water, we add the steam, and then we cook that. Therefore, basically, we are gelatinizing, the fancy word, cooking the starch. Then, of course, improve the digestibility. And also, it will bind your fat. Remember that one. Increase that also your water solubility. And also, it will increase your susceptibility to the enzyme. This is what happens to the starches when you go to the extruder. And remember that starches, when you get the raw starch, it also have a cook already 15%. Preconditioner, we can go around 32%. In extruder, we can go 90%. Even dryer, we can go to 96%, depending upon your setup. The average cook level of the extruded feed is 90%. That's why the extruders are more popular than the pellet mill. The pellet mill only give you 60% cook level. Because what happened if you don't have proper preconditioning, the pellet mill is going to bind the pellet together, just putting the ingredients together, not really cooking it. With the binder, like a tablet you eat every day in the medicine tablet, you see in the facility, you have different powders, add a little bit of water, a little bit of steam, and you binding the pellet together. And you eat it. Therefore, the cook doesn't take place that much. And you use the binder to bind it. Whereas in the extruder, we use starches to act as a binder. We cook very high temperature. Therefore, our average cook level of the dog food and aqua feed has to be around 90%. Okay? And even raw materials, starches get cook level. Where they get cook level? When you make the starches, you have a pellet, and then you grind them. Every time you give a heat treatment, you're going to cook the starch. Therefore, we're giving heat treatment during grinding it. We are already 15% cooked. In the preconditioner, we are heating it. You got already cooked there. In the barrel, we are giving the heat treatment. You got cooked there. In the dryers, we give the heat treatment for 15 minutes, 20 minutes to dry the material. We're giving cooking that. Therefore, you also have cook level in the dryer too as well. Also, different grains have different level of starches. Therefore, cannot you just say that, oh, I need to change my source from wheat to corn, corn to sorghum, sorghum to rice, because each of them give you different level of starches. Therefore, you have to make sure that what is your starch contribution, because we know that for making a fish feed, sinking one, we have to have 10% starch minimum, and making a floating feed, we have to have at least 20% starch. Otherwise, we will not make a good starch. Sometimes we say that supplier that giving you that, remember I told you in the previous slide here, different cereals have a different level of starches. One cereal, which is a wheat, the wheat also has a different varieties of wheat, and then it has different level of starches. You can see that starch level can go to around 60 to 62 to almost 55%. We have a red winter wheat, we have a red spring, we have a soft white, we have wheat flour, we have all-purpose flour. Therefore, just even within the same cereal, you will have different level of starches. Therefore, don't just assume that the supplier give you what kind of, one day they give you wheat, it has a 60% starch, other day give you which has a 55% starch. And you're going to say, oh, don't get floating. What happened? Your starch level reduced 5%. You call the extruder manufacturer, your extruder is not working. Extruder is working. Your formulation have changed without telling you. You didn't know you changed the formulation. The supplier gave you the wheat material, but different variety now. One variety has more starch, one has less starch. They come to you, you don't realize that. It's still the wheat and wheat, but starch level changes. When starch level changes, what happened then? Either you make it floating or make it sinking feed start floating. Oh, my feed does not sink 100%. It's floating. Even the same formulation. What happened? 5% floating. Why is floating? Because your starch level changed. More starch. Or sinking, you're not floating, you have less starch. Therefore, basically, to understand that. Also, this is the wheat one. What about cassava? You have cassava chips, cassava meal, cassava refuse, cassava flour. You look over here, starch level is different. Therefore, remember that what you are using, a cassava meal, a cassava chip, or refuse, whatever you're using it, they're going to provide you different level of starches. One day you use some of the chips, other day you use some of that cassava meal. Your starch level is going to be 7% difference here. 7% starch level difference. And that's going to change everything? Yes. Don't blame the extruder manufacturer. Don't call Buller, Winger, anybody there, or enters or call that your machine is not working. Machine is working perfectly. It is just you change your raw material without telling you, they change it. Also, why that's important, starch level, different ingredients, we have to know that each starch requires different moisture level to cook. Therefore, you can see here, different starches, we have different moisture level. Therefore, this is the one where we need to cook the starch. And also, same is true, all the starches are different level of temperature to cook them. Therefore, basically, not all the starches are the same. If you change the starches, you have to change the temperature, you have to change the moisture. And also, if not all the wheat is the same, remember that different variety have the same, different starch level. Same as rice. We have long grain rice. We have short grain rice, medium grain rice. The short grain rice is very sticky. We don't recommend them using it. But they are rice. They are different amylos and myelopectin. Therefore, medium grain rice, long grain rice, short grain rice, they all have different level of the myelopectins and behave differently. Similarly, you have different kind of varieties of wheat, 6 of them. Therefore, remember that you are talking about the starch, what is the cook level, how much we're going to do that, that's why it's going to work. Next one is, we're going to talk about your oil. What happened to the extruder? What's the fat level in your Aquafeed or in your pet food is going to affect that one. Remember, the fat is, how does the fat affect in the extrusion process? How it affect your expansion? How it affect your texture, durability? Is there a difference in the impact between the different fat sources? What other effect do we have fat? What is fat? Fat is lubricant. Okay? It works against the friction. We cook in the extruder with the friction, but now you're adding the fat. Therefore, basically, you are reducing your friction there. Therefore, when you have a raw materials go in the barrel, the screw will create a lot of friction. But once you add the fat into it, what's going to happen? It's not going to create any friction. Fat will lubricate your screws. It will lubricate it so that there is no more friction. That means no more cook. That means your pellet will be uncooked. Your kibble will be uncooked. Your dog will be losing motion, loose motion coming up there. Fish feed will throwing out because you have fat here and you reduce the friction. Give you example to my students. You have a door here and that door make a lot of noise. You go there and you drop oil there, 1 drop of oil in that hinges here. And you lubricate the hinges. Very nice, no more friction, very smooth, no more noise, clinking noise, right? Very, very smooth. What happens when you add more fat into your recipe? You lubricate the barrel. All the fat comes on the barrel. And then what happened that? When you have a lot of fat there, material slip. Material does not cook. You reduce the cooking. Material is going to slip there. Therefore, what happened that when you reduce that, you increase the slippage, you lubricate it, no more friction, decrease the temperature. I didn't change the fat. Well, your fish meal yesterday came as 7% fat, today it came 9% fat. Without telling you, you increased 2% fat. You got poultry meal, yesterday was 6% fat, today has 7% fat, 8% fat, 2% extra fat came from the fish meal, or poultry meal, or the bone meal, or your other raw material. And they don't tell you what's the composition is, you don't measure it, and you're changing your fat level without telling you, and you're lubricating it, and then you are claiming it, my pellet is not durable, it's not float, it's not sink, and you have a lot of issue with that because fat is a lubricant, okay? And the guidelines to give you 0 to 7% fat in the recipe, 0 to 7% fat in the recipe. You will not see any effect on the pellet. Pellet will be the durable. From 7 to 12% fat, every 1% extra fat going to increase your density 16 grams per liter. Therefore, you think about my density is increasing, my is not floating because you increase the internal fat. From 12 to 17% fat, product will be, you can make a pellet, do a little bit, make it a product, but it will no expansion at all. But you can still make a pellet. But above 70% pellet, your pellet is not durable. You're going to have a powder coming outside. Okay? These are the guidelines to keep that one in mind that what happened there. Therefore, just remember that you may not change the fat yourself. The raw material has variability. The fish meal, chicken meal, the bone meals, all that materials you're getting it, we have different level starches, soybean meal, cottonseed meal, sometimes they have more fat. Rice bran, one day rice bran have 15% fat, other they have 18% fat. You're adding the rice bran. And you 1 to 2% fat extra, going to change everything in the machine. Also, never add a liquid fat into your recipe, because once you add the fat into your recipe, in your raw material, what's going to happen? It's going to coat all your particles. It's going to coat over the particle of the raw material, and the water and steam will not go inside, because water and the oil don't mix together. They repel each other. Okay? Therefore, have you tried to adding the water and put some oil in it and mix? They will not mix, they're separate. Therefore, when you add the liquid fat is going to basically coat your particles outside the coat, and that water and steam will never go inside. It will slip outside. Therefore, basically, my point here is that if you have to add the fat, there's different way to add the fat. But do not add a liquid fat. Do not add a liquid fat into your recipe, because once you add the fat is going to coat all the particles outside that raw material. When you go to the preconditioner, you go to the barrel, you will have a hard time to inject the water and the steam not go inside. Water and steam will not go inside because it's coated. If water will repel the water, oil will going to repel the water out. Okay? But I do need to add fat. What do? You can choose some raw material which is indigenous, which is high in fat. For example, full fat soya. For example, rice bran. For some other ingredients which is high in internal fat inherently, rather than adding the liquid fat. This fat will have a less effect in the extruder as compared to adding a liquid fat. Okay? Also, you can add the fat as late as possible. Ideally, you can add the fat maybe in the end of the barrel, in the barrel, but it's not possible because very high pressure. Therefore, what we do here is we sometimes add the raw material in the preconditioner, end of the preconditioner. So, or do in the coating system, or do some other place, not in the raw material. Add as late as possible. And therefore, to maximize the fat, okay, this one is missing here. To maximize the fat also, you can heat the fat around 40 to 60 degrees before that. This is our facility here. We're heating the fat before that in the kettle. And then, of course, you can put it there also in the preconditioner. And then you can have a 40 to 60% fat there as well. Also remember that if you're going to add more fat, you can maximize your starch and functional protein. Remember that one of the functional protein is going to give you more expansion. If you want to add more fat, you're going to reduce the expansion. But you can increase your functional protein. You can increase your starch. You can still get the same expansion. Basically, there's other way to maximize the fat level, that increase your functional protein, increase your starch level so that does a rust effect. Other tip is that inject more thermal energy. A lot of times we have to inject more steam into it when you're adding the fat in the barrel or in the preconditioner, because that will help you to add more fat. Therefore, there's a different way to add the fat. One other way is that also, you can preheat it, add it at the end of the barrel, do different things. Also, sometime when you're adding the fat, your pellet is going to be dark color. And people think that it's too much moisture. They reduce the moisture. It's the opposite. You can have to increase the moisture. If you're adding the more fat, your moisture level has to be a little higher than that. And then still need more fat, you can also do a coating. You can do a surface coating. We do it all the times. This is that, you can see the fat raw pellet, pet food, then we did the coating. Less than 15%, this is our coating system. You can have oil there, you can coat that one, less than 15% easily. Again, this is the feed we made it, and then this is the coating. You can see at 15% very easily done. If you want more than that fat, you want more than 15% fat in salmon feed, we got 40%. How do you add the fat? Then you have to use it vacuum system. In this case, we add it vacuum here. We pull the vacuum here all the times, and then we can add liquid addition system, liquid fat, all the things in it, and then we do that one. So basically, you have to use a special vacuum system, which is expensive. After you make the feed, pull the vacuum into the feed, and then of course, inject your fat into it. Fat will go inside the pellet. Therefore, that's the way we make a salmon feed, which is 45% fat, 45% fat. And that pellet is still durable. Remember I told you that in the extruders, the single screw, we can't go more than 7% internal fat. But here we're making a pellet, 45%. How we do that? We use twin screw extruder, which allow you to put 70% fat inside. And then after that, we do some 5% fat in the end of the barrel. The rest of the fat, we do it on the coating system. Therefore, you have to use different strategies to add more fat. Therefore, what I recommend you, when you go home, you can make this table. That table basically tell you different raw material. What happens if I increase my starch to my density, to my product hardness, to my surface skin, more uniform, better shape? What happens if I add more oil? What happens if I add more fiber, functional protein, non-functional protein, rework? All these things is that what will happen to my formulation, what will happen to my finished product when I add these things, and this will help you to understand better. With that, minor ingredients that we add, they don't have any effect in the extruder. Most effect will be coming from protein, carbohydrates, and fat. But if you're adding some other minor things, the colors, the amino acid, vitamins, things like that, you don't see any changes in the extruder. But these three raw materials will change extruder very dramatically. Protein non-functional, you're not going to make it pellet. Carbohydrates are different level, you're going to get more expansion, less expansion. Fat, 1%, 2% extra fat is going to change everything in it. With that, once again, these are the books I showed you earlier. I put on each of my presentation end of that, just so you can see it. With that, any question on the raw materials? Okay, I gave 2 presentations. Now we can have a 5 minutes break only. Not 2 minutes, 5 minutes. We start exactly in 5 minutes. Thank you. And just if you want to see the books, you can see here. If you are interested in it, you can also have that. It's a very heavy book, actually, 5 pounds. You can pass that on the back.
Dr. Riaz?
Yes.
My name is Baki Wong from the Philippines.
Nice to meet you.
I'm actually from the food industry, so
Yeah.
I'm familiar with some
Excellent.
concepts. But I apologize I couldn't raise my hand more often because I bought a complete feed line, but it's not going to be commissioned until the middle of next year.
Oh, okay. Very good. Okay.
But can you tell me how we could get in touch?
Yeah,
get
you
a
can
copy of
you
it?
can Google it and see how much is the price. It's available only from Germany, and the shipping is very expensive. I think last time I saw that one, it was.
I actually have one of your books already on the right side.
Uh-huh.
The last one, yeah.
It's called extruder.
Is there a link or?
I will show you.
Yeah, okay.
Extruder and expander.
in pet food. Come on. I should pick up automatically. Okay, this is a book. This is 99 euro.
Erling. What's
Yeah, it's from Germany. Oh, come on.
Can I copy that?
Yeah,
website?
yes.
Sorry.
Okay.
Got it.
But if you want it, you can have this one. Just 99 euro. If you have it, you can. This
Do
is
you
this.
do you take PayPal?
Yeah,
Yeah. Okay.
yeah.
Okay, so-
This is 99 euro.
yeah. Okay.
The book,
okay.
and it's no shipping. Otherwise, when you buy from it there, it's going to cost you maybe $40 for shipping only from
And
Germany.
the other one? You had three.
I just have these two books.
Oh, okay.
This is the same book
Okay.
I have. If you are interested, you can have it. You can pay PayPal. You can pay however you want.
Do you have a PayPal address I can use?
Yes, I think I do. Financial, where is that? How do you use PayPal? I hear
Email
you.
address? I just need your PayPal email address.
MNRIAZ.
Oh, okay.
M.
Okay. Let me write it down somewhere.
I think M N
MN.
Riaz RIAZ at
Sorry.
Tamu TAMU.
Demo.
No, TAMU TAMU. Texas Tamu
Oh, okay.
TAMU.
TAMU.
U.edu.
Dot edu.
Yeah. Okay. This is one you can scan it too.
Oh, okay. Okay.
You should get that. You scan it. You take picture.
I scanned it. Let me try
No.
again.
This is the picture.
Let me try again.
This is the picture you're taking it.
Oh, okay. I can take it first. It won't open. I'll have to manually do it.
Okay.
Huh? I have your email address?
Yeah. This is the one you have. This personal P code. You can just see this one.
Okay.
Okay.
I'll do it in a while.
Yeah. Thank you. Okay. I got your slide here. You guys see this will work? The code? Yeah. Still can't find it?
Yeah, I think I got it. Is it? That's
Right.
this one, right?
Yeah, M and Riaz. Do you see my picture there?
Oh no, I didn't see it. Let's see. Pick a payment type to continue. Goods and services, right?
Yeah. Should, I think.
Okay.
This is, you can send it. Hopefully, it's my email address. Hopefully.
Here, this one.
M and Riaz at the
Okay,
PayPal
got it.
go with the email. I don't know how it works
It
even.
does.
Okay.
Yeah.
Okay, I got it.
Okay.
Yeah, I got it.
Thank you very much. Thank you.
Okay. Yeah, it's your book. Hi, how are you? Sorry. This was that code there if you want to scan that one, QR code. That's a free magazine that Roger was mentioning. Aquafeed and also Petfood magazine you can have online. You can just scan it and then do that. I give you extra 5 minutes, 10 minutes. Don't worry, you have plenty of time. Okay, guys, come back. We can start. Let me grab the book here just in case somebody else wants to see it. Does everybody have seen the book? Anybody want to see it? Okay, and this is a QR code for magazine mention about pet food and Aquafeed. If you want to see that one, just scan that one for getting the free online magazine reading. Next one, we're going to talk about, a lot of times when I travel, one of the largest issue is that how do I make my pellet float and sink? Even though I have a right extruders, right raw materials. Therefore, in this presentation, we're going to discuss about precision aquafeed manufacturing, floating and sinking diet. How do you make it either float or sink? Because when farmers buy that floating feed, they don't want anything to sink. And when they buy the sinking one, they don't want anything to float. Therefore, sometimes people say that, oh, you know what, I was making a 5% float, 5% sink, and why it's not 100% float, 100% sink? Therefore, as long as you have proper raw materials, your hardware, all these things, but there's some other techniques that will go with it, and you can make that one either floating and sinking. Therefore, basically, our goal here is to make it float and sink. But remember that Japanese now want slow sinking feed. Why is that? Because they have some medicated, they make some medication, they put it feed into it, and they want certain amount of velocity the product go down so that fish can come and eat it. If they're taking too long, that means your medication will go away, and they don't want to float. Therefore, they want certain speed. You can adjust, basically make it your feed to go with your own rate. You decide that how fast, how slow it goes. That's only control the density, and you can make it either slow sinking, fast sinking, 100% floating, or 100% sinking. Therefore, all that options are available. Therefore, in order to that, just understand, we talked earlier that we have a lot of different raw materials. What's the role of the extruder? We take all the raw materials, we basically cook it, we pasteurize it, and we make it either fish feed or make it dog food, pet food, whatever that is. Extruder is not a magic machine where you put some kind of junk and expect to get a very good quality. Whatever you put in the extruder, you're going to get outside. And I usually tell that somebody tells me that, Dr. Riaz, I know how to make good quality wine. I said, if you want to make good quality wine, you have to give me good quality grapes. I cannot make a wine from the water. You cannot make your feed from a very low quality raw material and expect to get a good quality machine. Extruders are not magic machine. They are basically processing machine. Whatever you add, you're going to get outside from the same thing. Okay? Therefore, basically, how do you control your floatability, sinkability, your density? That's controlled by 3 items, mostly. There's other things too, but we'll discuss mostly 3 of these things. Number 1 is your recipe. Remember I told you the starches, the fat, the protein. Composition wise, you can increase your fat level, you can making a sink. You increase your starch level, you can make it float. You can adjust your recipe. You can add a little more functional protein, you have more expansion. Number 2, process variables. I can change my process variable. I can change my screw speed. I can change my steam injection. I can change my water injection. I can change different hardware, different things like that. And I can do that one. And also sometimes we add extra things on it. We call it, like in the phone, iPhone, we call it apps. Usually in the extruder, we have different apps that we can add on to it that will make it float or sink. Therefore, what we discuss in this case, talk about raw material. You already talked about raw material, remember that? And I'm not going to go through that same slides again. This is a different presentation, but just to revise for you, just because I've skipped that slides, that we have a, how you control your floatability with the raw material. What is raw materials? We have a protein, carbohydrate, fat. And we learned about the protein. Therefore, we're going to skip that one, so we don't want to waste our time here. But this will make a float or sink. Therefore, this is a separate talk, which is talk about the same thing, but it's differently. Therefore, we will go back here, right here. Therefore, you have different fat level, different starches, and different kind of protein. And you can manipulate your protein, you can manipulate your lipids, you can manipulate your fibers, their interaction with the starches, and you can basically control your density. All these factors will play a role in the density of the finished product. Therefore, we talk about raw material. If I increase my functional protein, I can increase my floatability. I can increase my starch, I can increase my floatability. Increase my fat, I can make a sinking feed, reduce my floatability. Therefore, these are interaction. If you have a room in your recipe, most of the time, we don't have control on the recipe. We cannot change the formulation. If you have an option to change it, and you can tell your formulator add more starch, less fat, more functional protein, but your nutritionist comes in and tells, no, you cannot change the recipe. This is a fixed recipe, this is the customer demand, and we must have this much carbohydrate, we have this much protein, this much fat, you cannot change your recipe. Sorry. That option is gone. Adjusting your floatability, sinkability, that is with raw material. Next one. Then you can go to your, basically with your hardware. You can basically, with your variables, you can change energy input. How do we do that? I can add my more energy in order to make a float or sink. I can increase my RPM of the machine. I'm running 300 RPM and I'm making a sinking feed. I want to make a floating feed. I can increase that 300 to 400 RPM and then I can make a more energy into the extruder and I can make it more. How it works? If you rub your hand 300 times, or you're running 400 times faster, you're going to create more energy. More energy, going to give you more coke. And that means what? You're going to get more expansion. That means you're going to get 100% floating. Therefore, number one is that you can change your energy input. How do we do that? Number one, by increasing that RPM. Number two, feed rate. You can increase your feed rate. You can decrease your feed rate. If you increase your feed rate, you will have materials go very quickly. If you decrease your feed rate, you have more retention time. You have more cook. And if it is not floating, you will cook more floating. Therefore, you can basically decrease your feed rate or you increase your feed rate depending upon your requirement, and that will also affect on your floatability and sinkability. More feed rate, material is going to go very quick. Retention time in the barrel, 20 seconds, now it's going to be 15 seconds. You add slow feed rate, less feed rate, material is going to take more time to go through there. So basically, you can adjust your feed rate and do that one. And then also you can add more steam, energy, and moisture to do that one. Therefore, this is one way to change the energy input by the RPM, by the feed rate, by the temperature and the moisture added in the water. Therefore, you can do that by controlling that one. Second option is there. You can go inside your barrel and you can basically change your screw profiles. You can use more double flight. You can move some maybe reverse flight. You can use some of that shear locks. And you can use some cut flight. Anybody know what cut flight is for that? You can add a little bit more different kind of setup if you have option. Remember, you bought segmented jacketed extruder. Segmented, you got a lot of different screws. Therefore, basically, I can change my simple screws to cut flight screws. What's going to happen? This is my screw. Materials go on the flight, right? I cut flight. I miss the flight here. Materials cannot go forward. It's going to come back. But there's a lot of pressure from the back. Therefore, it's going to come back and forth, and it's going to create a very aggressive condition. Anytime you need more cook, anytime you have non-functional protein, anytime you have high-fat feed, anytime you want more expansion, just change 2 screws to cut flight. Cut flight is going to give you more friction, more cook. Understand that? Therefore, basically, that's going to help you too. Then, shear locks. You can add your different kind of shear locks. These are called shear locks, which basically help to mix the raw material. They help you to forward the raw material or reverse the raw material. You can put just shear locks, give you mixing. You can put a shear locks forward, it's going you mixing and going to move forward. You can put a reverse, give you mixing and reverse the material back. So basically, you have a lot of different options in the hardware to do that one. And just to give you some, you can change your dies, you can change your shear lock, you can change your screws inside to control the density with the hardware. And this is just to give you an idea, this is floating aquatic feed. And you can see here my setup, my screws here, shear locks. I am basically my SME, my retention time in that, my RPM are 400, 600, my moisture. This is setup I have for floating aquatic feed. And I am making it with that one, my floating feed. This is my processing conditions. Moisture is this much, cook level is this much, temperature is this much on the preconditioner. This is in the barrel. In the preconditioner, I have 1.5 to 2 minute retention time, and this is my barrel. Therefore, basically, I need to change my processing condition, and I can change my screw profile. I can make it from floating to sinking feed. What did I do my hardware? I changed my hardware. Look at over here. I put a vented barrel. You have a segmented barrel. One of the barrel is it's called vented. What that means, what the vent will do. You have materials comes up right here, all the way cooked. The shear locks from here, you can release a lot of steam and the pressure from the vent. And then you can densify your product, and that will sink. So basically, you are controlling your density. And you can have even put a vacuum on it. On this one here, to pull more vacuum here, more moisture from here. And you can see here your pressure drop here. And you can see here also I decrease my RPM to 400 to 350 PM. And also you can see here some changes between mostly the RPM. And I change this one here. My processing condition maybe stay the same, but now I'm getting a sinking feed. What did I do? All I did a vented barrel. I reduce my RPM. Reducing the RPM, I reducing my energy. By vented barrel, I releases all the pressure there. I releases all that steam goes outside in the air. So I can make it my sinking feed. Also, I can go in the die too. I can adjust my die opening and make it floating or sinking. How do I do that? I have this called low die resistance. Has a lot of opening here. You can see here my cook level is only on the right on the last barrel right here. Lot of pressure here, but there's no pressure, no cooking here. I can go and intentionally close some of that die hole. If I close some of the die hole here, I can increase my resistance, and I cook level go much better here on the back. My temperature, my pressure go very high, and instead of making sinking feed, I start making floating feed. Therefore, intentionally or unintentionally, your die holes plugged up. Either you go and purposely plug up, put small plastic beads inside so you can close it. that means you can make a floating feed. You open up, you can make sinking feed. It's that simple just by adjusting the die open area and all that. And I think I have small here video maybe that if that works here, we'll see. On this case, it was working this morning. Oh, no. It's supposed to work. I don't know what happened, but it was working this morning. No, it's not going to work. I don't know. Anyhow, you can see the picture here. Maybe just the picture will show you something here. It was, I closed some of that die opening. It was floating. You can see the expansion, and one was without that one. Therefore, maybe after that I can show you the video here when I finish my presentation, because I made that. What we're trying to do with that one, we're trying to adjust our density of the pellet. Therefore, your goal should be that you have to have a different kind of, these are just to give you idea, different species, what their requirements are, floating, sinking, slow sinking and sinking. These are the requirements for different species that they wanted. Because we have wide range of that we want to make it. How do you control that? By density. Therefore, basically, what you need to do here is adjust your density. That means fast sinking, it should be more than 640 grams per liter. And remember that if it's seawater or is it regular fresh water. Slow sinking, neutral, and floating. As long as you can control these densities here, you can guarantee that your pellet will be either float or sink. How do you do that? With the raw materials adjustment and some of them the processing variables by increasing or decreasing the RPM, decreasing and increasing that feed rate, by increasing and also opening the die open area, changing the screw profile. You can do that one. Well, these are some of the things that are available to you to do that. Then on the top of that, some of that extruder manufacturers giving you different tools to add on to your existing machine so you can make a float or sink. And there are different things that's available. These are almost 5 different options that we will discuss that one, that you can use it. Number one is that vented barrel we just discussed. Here is the example you can see here. This is that extruder and this is the vent. You can see the steam is coming up. So what happened here, that you're cooking it from here to here, and then you don't want the product to expand. Therefore, what you do, you release your pressure, your steam from there, and since they are segmented, jacketed, first few jackets, you're running a steam in the jacket to heat the barrel. After the vent, you can run chill water to cool the product. So you properly cook, but does not expand. Therefore, basically, a lot of people have misconception that floating need high temperature, more cook than the sinking one. The both are, we're going to feed to the fish. Fish are animal, they need same cook level. Same cook level as a floating, same cook level as a sinking. And I was told just last week I was in Egypt, if we give more cook to that sinking, they start floating. Well, you need to adjust that. You still have to have 90% cook. You can't feed the fish uncooked. Therefore, some of the vented barrel, for the medium density, you can release some of the pressure here. You can add some vacuum assist, even more heavy density. You can close the vent and you can inject the steam for the lighter density. You can close this vent even and inject steam here to make it lighter. Therefore, you have a lot of option. All you need to do is just buy this vented barrel. One barrel will be vented. So you can play with that one. Open half. The plate comes on the top. Full plate or half plate. You can even open half or you open full. Okay? And you can put there. You have to learn about how to put together, because this is you're going to be conveying screw. There's a lot of shear locks. After the shear locks, you need to make sure that there's no pressure here. Otherwise, material will start coming from here. And here we have a special screw, conveying screw, so that it does not give too much friction cooking there. Otherwise, your material will start coming from the vent. Therefore, you want to here properly cook. Here is your different kind of shear locks. And then from here, you put a conveying screw up till here outside the barrel. You're running the steam or heating oil. Last one after this one, you're running chill water. So you're cooking it properly, but you are not expanding the pellet. You want to cook the pellet, but not to expand the pellet. Understand that? And you can go one step further. You can have, this is a barrel, and you can put some kind of vacuum on it, collect your fines, collect your water here, and recycle that in the system. Therefore, basically, you're collecting all the water and the fines from there, steam, injection, everything, then you will add that one. It will improve your pellet durability, increase your piece density, reduce your extruded moisture level also. You're pulling right home a lot of moisture right here into that system. And that will make your density. But again, every of these things has some benefit, advantages and disadvantages. Disadvantages here is that hardware investment, you have to buy extra tools, these things. Potential capacity of extruder reduces 25. You're putting a vacuum now. Vent, you can run full capacity. Disposal of water and the product fines from the vent, you have to make sure that your water and the suppose have properly disposed and go back to the extrusion system. And you can, not that much, but you can control the density as an SME as well. Number two, you can have two separate extruder, cooking and farming. And you can make a floating and sinking. This is the extruder. You can see the vent is closed. It's fully cooking it. After cooking it, full capacity, and then we are taking this one from the tube to go to the farmer. And then here we are making it full capacity, making it sinking feed. We are forming the pellet so that it will sink, it not expand. Therefore, you're using two different extruders, different concept. In this case, two separate extruders. First extruder used for the expanded product. Second is for the farming. Second farming extruder is just used when processing the dense product, otherwise you don't use that one. Again, advantages, disadvantages. Both extruders can be run, operated at maximum rate potential, wide density range, 100% floating, 100% sinking. Disadvantage, more capital, and idle. When you are making a light dense, when you're making floating one, this is going to sit idle. You're not going to use that one. But advantage is that you can run both full capacity and you can make a 100% sinking feed. But that's option also, people are using that one. Other one is called a restriction well inside the extruder barrel, MBP, mid barrel well. What that means that you can put here controlling your density, some of the mid barrel well, and you can open them and close them. When you open and close some of them, you can see your SME will go up, and your density will go higher or lower depending upon what you needed. Therefore, basically, you can see here your density go very, very low, 275 grams per liter. Here is 430, and you are doing it, closing it, or opening these basically mid-barrel bell, they call it. You open and close them, and then that materials go there, increase your SME, and that will give you more cook or less cook. Other one is called back pressure valve, restriction valve at the end of the barrel. Remember that in my presentation you saw that kind of screw extruder there, and this is just before the die. This is the die. It basically restriction valve right here, located just that SME and the pressure here, called back pressure valve. The benefit of this one here first is that when you start your machine, first 10 to 15 minutes you have uncooked material. It does not reach proper temperature. You have to recycle that material again. You cannot mix that material because when you start your machine, high moisture, low temperature, it takes 10 minutes to 15 minutes before you optimize your condition, before you're getting correct your temperature for the pet food, for the aqua feed. Therefore, what you do here is that in this case, you can have a well, you can have a reject position, you can selecting all your material here in the bin. This way you don't contaminate your die, you don't contaminate your conveyor, you don't contaminate your other stuff because it's very clean. And when you get proper temperature, proper pressure, when you got everything proper cook, then you can change your flow and then material start coming from the die here and you can start collecting it. Now, that's one of the other benefits you have with this one, that you can reject the material when it is not properly cooked. and then also you can start collecting the material when it's properly cooked. Other thing is, you're making 5 millimeter, 6 millimeter, you want to change the die. How you change the die? You shut down the machine, open the die. In this case, you can reject your material flow. Within 5 minutes, you change the die from 3 millimeter to 5 millimeter and turn back the machine. Therefore, you diverted the flow. Other benefit, you're running it, your knife broke. When your knife broke, you have to shut down the machine and change the knife. Here, if your knife broke, you can reject it and immediately change this, put the new knife and then go back there. Therefore, there's a lot of benefit comes with that kind of machine. But also the main benefit is that it will, of course, control your density, making it float or sink. Therefore, some of the benefit are, we talk about it, you can divert the off-spec product for sanitary reason, for the quality, service die knife, online adjustment. That means you can open or close online so that you can adjust your density, your cook level, your shape, your water, your stability. Eliminate extruder configuration. You do not need to change your configuration now because you are adjusting your SME through where? Through the back pressure valve. Therefore, you don't have a configuration. You have two big shafts. Remember that? They are tapered one, 3:1 compression ratio. And otherwise, you are making floating and sinking, you have to change your configuration. In this case, you don't need to change your configuration. You basically just adjust this one. And this is to just give you some data. Back pressure close 50, 60, 70, 80. Your density 440 to 380, 358. Dry density, SME, you can see that you can decrease and increase. Therefore, basically, there are a lot of different benefits with that one that you can get there by using that one. The last one is called pressure chamber at the extruder die. That is other technology that's available. And this one is after the die. The first one was before the die. This is after the die. That what it does, it basically controls the exit pressure called ECS, and pressure inside the knife housing where the water from the product evaporate is controlled the accuracy. Now you understand that we are running extruder barrel, very high pressure, roughly 70, 80 bar. Okay, you can multiply by 15 psi or roughly, you can get how much psi at the inside. Outside is 1 bar, 15 psi we have just like our temperature. When the pellet comes from 70 bar from the extruders to the atmosphere, what happened? There's a moisture inside the pellet. The moisture will come and convert into steam and try to escape from that pellet, open the pores and make it light. That's why we make a floating feed. What happened? Pellet come from inside the barrel to outside. In the outside, it basically moisture is going to evaporate 4 to 7% from the pellet. Once evaporate, how evaporate? It open the pores in the pellet. So water in the form of steam get out from the pellet. What this does, this one here, it control, there is here is the, here has a control, we have here lock system here. The pellet does not go outside. The pressure inside the knife and the water is controlled by the accuracy. We basically regulate the pressure inside and making expansion our own, whatever we needed. What temperature water boil? 100 degrees C. Therefore, when it comes outside here, materials comes outside here, we are controlling it, our evaporation of the water, by controlling that temperature. If you look over here at 1 bar, water will boil at 100 degrees C. If I increase the pressure here, 1.5, my boiling point go up, my density go increase. The moisture will not evaporate from the pellet. It does not make it lighter. If I increasing my pressure 2.5, my temperature go 128. But basically, I'm changing the boiling point of the water inside that chamber, which is locked with a rotary lock. Therefore, inside here, I put a pressure lock here, and therefore water is not going, and I'm increasing the pressure. If I increase the pressure, temperature of the water going up and up and up to evaporate. Therefore, basically what happened there, 100 degree, I make it 120. Therefore, it's basically increasing the pressure in the chamber, and then water will not escape. When the water will not escape from the pellet become dense and come outside as 100% sinking feed. Very, very common with the Andres equipments. They sell these units everywhere in Turkey. Everywhere you go, they're using ESM system up there because they make all sinking feed for their sea beams and other species, all sinking. And this guarantee you 100% sinking feed. So basically what you do here is that you easy and precisely control the product density. Bulk density can be 550 to 600 grams per liter. Pressure affects the boiling point of the water, increasing the capacity, less demand on the raw material quality, no addition of the oil to change the expansion. This way you are controlling your expansion by just increasing the pressure of inside that area, and then you can do that. Clear? Then sometimes we also use back pressure valve with this unit as well. You can do it both together. Density control with the valve plus minus 20, density control with this pressure chamber 20. You use both together, you can go to 30 plus. But basically, your goal is to control the density. You can control with the raw material. You can do it with your processing variables, or you can add something on it, on the end, and then you can control it. Because our goal here is that we are adjusting that for slow sinking or fast sinking, that we want to adjust your density. So either it's float, slow sink, or sink. Therefore, summary is product density is crucial. Control the knife. Sinking can be done by recipe adjustment, process variable, not including recipe changes, and the hardware tool. You can do all these things and you can make any kind of feed you want, it floating or sinking. But basically, you have different options available to you. Same as a phone, you have different apps. Similarly here you have different apps, and then you can basically go ahead and add something extra on it if you want it. If you can control with your recipe, it's not option to you, variable, it doesn't work, then you can add one of these tools on it and you will be able to make it with that one. Any question about floating and sinking? Okay, I have one last presentation and we have 2 minutes that I can change over, and we start in 2 minutes. The last one is going to be very interesting, going to be troubleshooting. We're just going to give 2 minutes. I just want to check the book is there. If anybody want to see the book? Everybody's seen the book, right? Finish at 11:30, right? Yeah. 45 minutes, right? Yeah. Okay, perfect. Okay. Sorry, this is the last time you're going to hear me. Then after that, I'm done. You have a new speaker. Okay, that's it's called about kind of troubleshooting. Talk about problem to performance. How do you fine-tune some of the product? And this is going to be kind of summary that we discuss, but a different way that I will explain to you that how it works. How many of you think this is a smooth operation? It's running fine, the extruder. But apparently sometimes it was not maintained properly maybe, and it was not properly, it may be working properly, but again, you can see here everything on that one. that if it's not smoothly running, of course, we don't know that unless we figure out what's production we're getting from there. Once again, we're going to go and discuss 4 areas. Common issue related to that, we talk about raw material, we talk about hardware, talk about software, and final product specification. Anytime you want to make it pet food, dog food, anything like that, go to this 4th area of concentration. Let's say the farmer comes to you, tell me I need a 3 millimeter floating fish feed with 60% protein. Therefore, you need to go and see what raw material I needed to make a 60% protein or 50% protein. How much starch do I need to make it floating? Then they said I need a 3 millimeter. Therefore, you need to see that do you have dye for 3 millimeter, your hardware. Then you say software, that what RPM do I need to run? How much steam do I need to run? How much water do I need to run? Therefore, basically you understand your final product specification, that I want to make a floating, this much protein, this is the size. Then you go back, you see what's the raw material is going to be, what's my hardware going to be, what's my software going to be. Okay, raw material. You know, we do not manufacture raw material. Nature made it. Okay, sometimes the nature, we have more rain, sometimes we have less rain. Sometimes we have cold weather, sometimes we have hot weather. That all affect the composition of the raw materials. Therefore, basically, you will see that sometimes we have different raw material varieties, specifications, you get a lot of variability, storage issues, and all that, and processing, and then of a record. These are some of the raw material characteristics we look for that, see that where the variation coming from. Growing conditions, harvesting conditions. Sometimes we have a lot of dry season, sometimes we have a lot of rainy season. Therefore, basically what happens is that when you harvest during the rainy season, you have to have more moisture. If you are a feed miller, you go there, or if you are a flour miller, that you have to add a little bit of water into that when you do that wheat milling. Therefore, they can extract more starches. Therefore, let's say you're adding a wheat milling, that is 14% starch, 15% starch. Rainy season, if it's harvested, you may not get the same level of starch. Therefore, depending upon that, dry season also will affect the protein levels. Dry season also affect about the more protein and less protein. You do not have control over there because you do not manufacture raw material. Nature makes the raw materials, and sometimes that changes. Sometimes we have a soybean grown North Dakota to South Dakota. Both are different because soil fertility, elevation, the temperature. The soybean getting from the US, soybean getting from Brazil, soybean getting from Argentina, soybean getting from India, all different. Why? Because they are different harvesting season, different altitude, different soil fertility, different environment, and different weathers, different conditions. Therefore, all that is effect on your protein composition, your starch composition, your fat compositions, and these conditions, therefore, you have no control over. You're going to get what you're going to get. Right now, if you heard it, there's a lot of flooding going on in India and Pakistan, and all the flooding is going to affect all the crops are wet. When they're going to harvest, the raw material is not going to be the same. Okay? Just remember that. Number 2, storage and processing step. When you grind it and when you process it. Sometimes people say, okay, we can grind all for the week raw material and store it in the bin. What happens when you grind the raw materials? You're opening the cell, you're breaking the cell wall. Therefore, if your raw material has some oil in it, soybeans and all that, that oil will start coming outside and coating all your particles. Remember that, my raw material talk? You have soybean, oil is inside. You can keep it for 1 year. Who cares? As soon as you grind the soybean, it's open the surface, break the cell wall, everything is open. And when you mix with the raw material, oil will start penetrating to the other material. Therefore, you don't have proper cook of the other material. Therefore, maximum 2 hours. You grind it and you process it. For some reason, your extruder have some issues. You have to keep it for 1 day. You bet you're not going to get the same product next day. It will give you variation. Therefore, don't start grinding the raw material in advance. You have to grind it and use it. Grind it and use it. And therefore, Also, same is mixing. You can grind separately. When you start mixing it, your moisture will start migrating it, your fat will start migrating it. Therefore, if you keep it mixed for a long time and run it, it will not give you the same result. Just by time of the raw materials, once you grind it, once you mix it. I hope I made a point very clear. Because once you grind it, you open the cell structures, you break the cell wall, and materials start coming, moisture and water start coming outside, and start mixing with other material, and you're having a hard time. Also, I am not a serial chemist, but this is called after ripening effect. Sometimes the freshly harvested, most of the extruder manufacturers start getting complaint when they get new crops. Freshly harvested grains, especially the rice, behave differently when you keep it rice for 6 months, and then they behave differently, cook differently, because they are breathing. They are basically a lot of biochemical changes take place in that one. Therefore, always the old grains work a little better than freshly harvested, because they have not adjusted their biochemical changes. Therefore, every time you see the new crops comes in, you will have an issue in the extruder. There's nothing wrong with the extruder, nothing wrong with that raw material. It's a freshly harvested crop. Therefore, if you've been using a rice, older rice, at home, you see that freshly harvested rice you cook at home is sticky. Freshly harvested rice will never cook very properly. You have to keep it for 6 months. Old rice, that cook much better. Okay? Therefore, basically, there are some biochemical changes take place, and that improves the storage time. Therefore, that also you have to keep in mind when you are harvesting it freshly, using fresh your raw material, it's going to have different result. You saw this next slide. Again, same variety, but it's a hard red or a durum. Same wheat variety, only wheat, but different varieties, they have different starch level. Therefore, just don't assume that it's going to be the same. Also, rework, and I hope you don't have rework or reject when it comes into you. That is basically material which has already been cooked. Therefore, a lot of times people want to use that. Remember I told you 80 to 85% cost of the raw material. The pet food and aquafeed is raw material. 85% cost of the raw material, pet food and aquafeed is raw material. Therefore, let's say the farmer return comes to you back. It's out of spec. It doesn't float. It doesn't sink. You can rework it. But remember that you can only rework it 5 to 10%. It's going to give you darker color. It's going to give you less expansion, higher density, higher level of cook, and more defined shape because it's been already cooked. Remember that fish meal example I gave you in the morning? You already make the feed, and it came back as a reject. A lot of money. You have to grind it and use it. But don't use it all in one recipe. Use it 5% to 10%, mix in every time. So it does have a minimum effect. If you use all the rework at the same time, you won't have a lot of variation there. Same thing is byproduct. Wheat bran, wheat milling, rice bran, DDG, they are going to be different every time. Because I told you that rice bran could have 16% fat, could have 14% fat. Wheat milling, very typical example, whenever it's rain, the wheat milling has less starch. And there's a lot of complaint come that time to extruder manufacturer, we can't make a floating feed. So always keep a sample and compare that one with the new raw material. Because when there's weather changes, something happen, you will have a different byproducts because you don't control the byproduct. Your feed miller control the byproduct. Person who's processing the wheat control that what's going to be in the byproduct. How much starch I can give to you. He can give you one day starch 15%, other day 16%. Same as rice bran, different starch level fat. Therefore, they can give you all different kind of things there. Therefore, you have to be very, very careful. And therefore, all that byproducts going to be different. Therefore, you have to be consider that. Also, I hope you don't have this issue here, the white stuff. That comes from the fish meal. You can see that one. That is basically phosphorus and calcium. Generally, from the fish meal, it has insoluble minerals. Therefore, eventually, you're going to see that on the dye, on the back of the dye, you're going to have a lot of white stuff coming out from there if you have good quality fish meal. And that usually happen is that it's the high level of salt that fish meals come from there, certain species that has much more calcium, and then you will have excessive preconditioning temperature you have to give them, poor cooling, and you will have this kind of dye on the end that everything plugged up with the white. And this is not your control. It was fish meal you're getting it, high in salt, high in bones, high in phosphorus, and that's a different species they got it, they gave it to you as fish meal. Therefore, remember that these are the things you have to pay attention when you're collecting that, because it could have an issue with that. Not only plant-based material talking you white products, but also animal-based, which is the fish meal, leche meal, all that, more bones, more issues going to happen that one. Therefore, everything depends upon the recipe. Okay? You have to have proper recipe. You have to have different your recipe when materials comes in. You can see here the different grains, different sizes. Therefore, what you do here, you take all the raw materials and you grind the raw materials so that it's properly grind and mix and go into the extruder. And our goal here is to take these materials, go into the extruders, and then you will have this kind of nice palette there. Therefore, you need to prepare your raw material fine. When you cook some vegetable at home, you buy the vegetable. You don't throw in the pot. You take it, you wash it, you peel them, you cut them, you prepare them. Similarly, the recipe, you get it, you grind it, you prepare it. And rule of thumb is that here is that 2 recipe, pet food, same recipe 100%, same formula, same extruder, same processing parameter, only difference is grind size. One is ground 1 millimeter, other is 1.5. Therefore, basically you can see much more expansion, no more fines, nice palette. Which one the farmer is going to buy it? A consumer is going to buy it. Who buy the pet food? Consumer. You, me buy the pet food. When I see the rough surface, I'm not going to buy it. When I see a clean surface, yes, much better. Therefore, rule of thumb is that you have to grind it maybe 1/3 of the die opening. And no, it was 1 millimeter, no, it's got a 0.8, not to exceed 0.8 millimeter. Like means if you have 3 millimeter pallet, 1/3 will be 1 millimeter. But if you have 6 millimeter pallet, 1/3 will be 2 millimeter, but never to exceed 0.8. Extruders are not grinder. Although they can grind the raw material, but they're going to spend a lot of energy grinding it and then cooking it. Your production will go down and your hardware, your wear and tear go higher. Therefore, let hammer mill, roller mill do their work. Grind them, not extruder grind the raw material. Here's another example for the pet treats. You can see here, just grind size, it will improve that appearance of that finished good pet food. You can see here how nice that look like as compared to this one. And of course, this is some of the benefit. You have reduced incident of the die orifice plugging. You don't plug that one. And there's a lot of other benefit comes from proper grinding as well. Number one is that you have a much easy cooking. What happened? You grind the particles very fine. You increase the surface area of the raw material. The water and steam will inject very nicely inside that. You have proper cook level. If you have bigger pieces, water will not go inside. Steam will not go inside. There will be uncooked material. That's one of the reasons they say 5% are floating, sinking, because that small particle never got cooked, because it is still big pieces. Also, when you ship material from here to other place, roads are bumpy sometimes, and you break a lot of fines, break the pallets or fines. How you get the fines? Exactly where the big pieces are, not properly ground, that's the breaking point. That's where the pallet is going to break. Okay? Therefore, make sure that the pallet is going to break there. Therefore, you have a lot of fines, a lot of brokerage area. You don't want that to happen. Also, with that one, you can increase the water stability, lower density, softer texture, high level starch cooking, higher throughput, less wear and tear in the extruder, low microbial survival rate, improved digestibility. These are just some of the benefit you get from proper grind size. And if you are doing a coating on the pallet, make sure that at that time, this is fine grind pallet. Under microscope, you can see the cell structure. As compared to this is a coarse grind cell structure. The water, when you coat them with the oil will go inside and never come out. So you can see the leakage. Sometimes you have a feed sitting on that bag and bag got oily, oil start coming outside that pallet, because coarse grinding give you a poor cell structure, and that fat will coming out from here. whereas in this case, fat will stay inside. Therefore, there are a lot of benefits just to give you idea about the raw material proper grinding. Therefore, we discuss about raw materials variability, raw material grinding and mixing, talk about raw materials also preparation. They all will affect you to make a fine-tune your product. Number 2 is the hardware. Have you put your machine together correctly? Also, do you have some kind of, what's condition of your screws? Do you have some of the records written, everything like that? But basically, you can see that's the old-fashioned extruder. This is the latest one. Therefore, you need to choose first your extruder, whoever you have it. Good equipment, you have full support, commitment, innovation there. Then, of course, you want to decide you want single or twin. I talk about single and twins limit. We talk about single and twin also shear. We skip that one. We talk about different portion of the hard machine there. And then also you want to make sure that when you put your machine together, everything, you have proper liquid addition, proper configuration of your preconditioner, extruder configuration, extruder barrel configuration, die configuration. You need to check every single thing before you start your machine. It's like the same, I always tell to that, when the pilot take off and he has checklist. Okay, light is on, yes, pressure is on, yes, this is on, fan is on, this is on, this is on, yes. Once you take off, you have no option. When you start the extruder and your steam is not coming in, you are stuck. Your water is not coming in, you are stuck. Your knife is not properly working, you are stuck. So basically, you need to make sure that you have everything you check in advance, have a checklist, and make sure that everything is working. Then we also talk about selecting the proper preconditioner, and we now discuss, this is what happened also in the preconditioner. If you don't select properly, the nozzle even, inside the nozzle of the preconditioner, sometimes they have water coming out, it's one place, sometimes you have properly spray water inside. Therefore, what is that? Tells me this is uneven hydration. Water nozzle spray pattern, water injection, location of the water in the preconditioner vent. Therefore, you do not want this thing happen, uneven hydration. You want every single particle has to be properly hydrated. In this case, you have some are bigger pieces. If the water didn't hydrate here, that will not cook properly. Smaller will be cooked properly. You can see the color changes also, yellow to the white. Therefore, this will also have different effect there as well. Then you want to make sure that you set up your preconditioner right. You have single or twin or whatever knife. You have proper setup your configuration of the dies, your knife, your screws all set up properly. And sometimes people don't realize that they can put one wrong screw and then machine's jammed up. It's much easier to do in a single. You can set up easily. Twin screw is more sophisticated. If you need some more knowledge how to put the machine together, you will make sure everything is correct. Set up correct configuration for everything. And then again, this is configuration, we talk about it. Your configuration is correct. You put the proper shear locks, proper screws, everything is proper. Then also, you can see there when you're configuring it, what kind of screw you are using it. You have a medium shear, high shear, cut flight, reverse screw, all that is option to you. You want to make sure that you're picking the right screws for your setup. And then that will give you some kind of configuration here that you can get that one for your machine, and then you can make it floating and sinking. Therefore, I put two configuration together. This is one will going to give me sinking feed because I did not put too much shear locks. I didn't put cut flight, and it's simple one. It will give me sinking feed. This one going to give me floating feed. Therefore, you have to understand that how it's going to work in your system, how you want to put together a proper configuration. Then also how you put together your knife, because sometimes we have too many knives, sometimes we have not enough knife. Therefore, you need to understand what's the capacity, how many knife do I need it, what's RPM do I need to run it, and then you will be able to do that one. Therefore, it's not that easy. You have to set up the knife very nicely, and again, it's the whole talk, how you pick up the knife, how you design the knife, how many opening the die holes here, and how you run it for big capacity, what kind of die do you have it, all that will affect that one. And then, of course, this is a rule of thumb, that die open area, you properly pick up the die based upon your whatever you're making, expanded product, moderately expanded product, slightly expanded product. You have to have this much open area, 200 to 250 millimeter, and then also 325, 375, 505. This is one going to give you different kind of the pallet. And again, I show you that one earlier. The die, you can put this run die, and let's see if this video works. This is still not working. Sorry, guys. But you can see here, this is the dense pallet coming up because I have too many open area, and then I close some of them, and I can see it start expanding. And also, the die orifice, die design. This one has long length. This is going to give you much more motor load. Density is going to be a little 304 like this one. More cook here, smooth surface. I change the die land into this kind with the angle 45 maybe, make a smaller land. Now I can, my motor load go down, my density go change, my organization go lower, and I can have different shapes. So just ending the die insert will affect that one as well. Okay. Then also you need to check on there your hardware, your screws. This is the wear and tear of the screws. This is the metal contact. You have this kind of wear, chemical corrosion, this kind of wear and tear. This is normal wear and tear. And this picture will show you that all different kind of abuse you can do it. Abrasion wears, forging, this one is hitting with the barrel. Corrosion wears, all that is happen because if you don't careful that, and they will not make a good quality product if you have a lot of wear and tear on your screw. You have to check that all the time. Therefore, learn about your hardware, how that, if its configuration was right. It's a wear and tear, what happened to that. And then you go to your software. What are the softwares? That my prepare utilities, my steam injection, my water injections, my pre-run, my control, my upstream and downstream records, all that things, I need to check that one. Therefore, you have proper processing conditions, you have computer control there, you have a manual system there, you want to see if what is going on what. Therefore, guidelines are for the utilities. This is a supply pressure, water to preconditioner, water to barrel, water to thermal jacket, steam to preconditioner, steam to barrel, steam to thermal jacket, compressed air. This working pressure. Make sure before you start it, you have all these things there. And if you don't have the proper pressures, you will not be able to use it into the barrel, into the preconditioner. Then also have lubrication guidelines. If you're running bearings more than 500 RPM, lubricate weekly. Bearing running less than 500 RPM, maybe monthly. Gearbox service every 3,000 hours. Make sure you maintain the machine in order to do that one. Sometimes when we inject the steam in the preconditioner, we have 2 bars and we're pushing 8% steam and we're getting 85. Sometimes we want to increase more steam into it because we want high temperature. You increase the pressure from 2 bar to 4 bar. Okay, when you do that, you can get a high temperature, but you're wasting a lot of your steam going to the air. Therefore, pay attention to that. Therefore, extruder is just one part of the whole system. You have before that, maybe you issue with the raw material, issue your mixing, issue basically conveying steam, downstream equipment, issue maybe with your dryer, issue maybe with your coating system. Don't blame only the extruder. Look other things before and after that. Give you an idea. You have a pneumatic system that you are taking your product from the extruder to the dryer. The pneumatic system, some reason broke. Now you're using a conveying system. The product is going to be the same density. Just a conveying after the extruder, it may change. I don't have time to ask you why, but I can explain you why. When pneumatic system is pulling that, your pallet, putting the air on the die continuously, the die is getting cooler. Pneumatic air comes and suck the material, and continuous air on the die will make it die very cool. Okay, that means more resistance. Whereas in the conveyor, you are not putting any more air on the die. The die getting hotter and hotter and hotter. Therefore, when your product comes out, it may be more floating. Therefore, just by changing the conveying system on the end, it can change your floatability and sinkability, but we never pay attention. We always blame the extruder. But it could be your pre and post other things that we also need to be careful with that one. The last few minutes, we're going to do it common causes for the specific challenge, troubleshooting, some guidelines. What causes non-uniform pallet sizes? Sometimes they say we have non-uniform pallet sizes. It could be a missing, a broken knife, improper die flow, either too much die open area, more steam, die hole not symmetrical, not using back pressure valve, fat and other liquids blended not properly, and also extruder temperature is too high. That's when you get it your uneven or your pellet size, non-uniform pellet size. To reduce the density, a lot of people tell me my density is very high. You can increase the thermal energy, the steam, hot water, or maybe increase retention time preconditioner to increase the mechanical energy. You can increase the screw speed, more aggressive extruder configuration, decrease the rate, decrease the die open area, and increase the die restriction. Therefore, you can reduce your density. Opposite, you do it when you want to increase the density. Okay? Therefore, basically, this is just some of the guidelines that you can do the troubleshooting. Causes of surging. Everybody knows surging is, it comes and go, back and forth, surge all the times. That could be that you have a lot of wear and tear on your extruders, non-uniform feed delivery, bell temperature is too high, too much steam injection, moisture level is too low, incorrect open area. Therefore, you can see that causes giving you that uneven, giving you the surging there taking place. Then sometimes we have multi-layered product there like that. That is because increased steam and water DDC preconditioner improve mixing in the extruder configuration that will not have this kind of lining on that one. Sometimes we have a rough surfaces of the product. That means you're too hot, too much mechanical energy, too dry, die landless too long, grind too coarse, and harsh handling will give you this kind of condition there as well. Sometimes we have wedge product, like that kind of product. It's not round, it's always wedge. That means too dry, too hot, knife speed too slow. And the pellet comes and hit back of the knife. We are running too slow. Knife blade is too wide and poor die flow. That will give you this issue with that, you have wedging area. Breakage, too much breakage, not pellet is durable. Decrease the fat level, internal fat level, use more functional protein, increase cook of the product by SME, steam and water, make sure die flow problem doesn't work that way. Non-uniform product dimension, again we talked about earlier, this is some of the issue happen there. Causes of poor cut, you can see here, some of them have poor cut on that by Petfood. What happened that one? That knife blades dull, knife blades not set close to the die, insert not flush, worn die opening, die face is not parallel to the knife. Therefore, these are the reason that you can have a poor cut. Also, you can see you can have chain that people are saying my products are sticking together, chaining like that one. That comes from that extruder. That means called chaining, tails, discarded product. That's the result of the poor cut. That happen always because your knife is not sharp, so you're not getting that one. Therefore, there's techniques there to how you set up the knife. This is the worn blades showing you that one. Insert adjustment, the blade, incorrect adjustment. Knife, here is the bent knife. Therefore, you need to make sure that knife is the end. And then, of course, if you're not properly set up your knife, your product is not going to go make a nice shape there. Either it will be dull or it will be chain or do something like that. Therefore, in order to do that one, there are knife adjustment. Here you can see here. In this case, excessive clearance between the die opening and the knife. Here is that metal to metal. It's putting some of the scratches on the die here. Therefore, it's going to be hitting the die always. Therefore, you want to break that one. Final one. Ensuring a smooth running means final product specification. What is the result of the first three I told you? The raw materials, the hardware, software, your recipe, your software, and then you can do different things. For that, we have a lot of monitor our some of that parameters. You can do it online, right here on the extruder, or you can do a lab testing, or you can do some of that feeding trial that take long time. But basically, most of the people are getting now, they're doing it either online look at it, or inline, or of course offline. Inline means you're putting right on the barrel. Offline, you move the product a little side, or you can do it offline, bring the product in the lab, and then do the testing. Therefore, this may be exaggeration, too many instruments. You don't want that many instruments, but there's a lot of instruments available to you to measure the density, to moisture, the temperature, the pressure, everything like that. Therefore, basically, you have advanced online analysis for Aquafeed especially. You have it monitor control that technical and quality online. You can do that one. You have real-time display of the product. You can have reduced reliance on the labor sampling test and you can basically decouple personal from the product safety. You can do a lot of different things on the computer control here. You can measure everything online when you're sitting in the control room there. Here's some example that here is my batch mixer, and here is that I can put some particle size analyzer. I can put an NIR. I can put my bulk density measurement system there. They all are available online that you can put it there. You can measure your water activity, your color, your fat absorption right in the whole system depending upon what you want to do it, where you want to do it. You can do it in that batch mixing. You can do it in the preconditioner. You can do it in the dryer. You can do it in a coating system, cooling system. You can measure that everything online and without any issue with that. That's all the systems are available. Therefore, basically, inline density measurement, you can do that one coming from the preconditioner or coming from the extruder and then go to the dryer, because it gives you accurate result after every 45 seconds. Therefore, you do not have to wait for 2-3 hours. Traditionally, people will measure it with this kind of system, and this basically sampling, eliminate operator errors. Sometimes they don't, they just take it one and keep it there because they don't want to go up and down all the times. They say, oh, we just took it. And this gives you, sometimes people shake the cups, level it. Sometimes I get you, if you are two people take the density will be both different because they both are measured differently. Collection locations, collection method, but this will give you online everything. Therefore, if you have it, you can see here the variation. This is the operator sampling, and this was the instrument sampling. And you get maybe less than 1% variation there when you do that. How it works is that basically, in this case, this things comes outside, take the sample, scrap the sample, machine does it, and then of course sample ready for the density, and then empty it. Therefore, you can put it on your, going into the dryers, going into the extruder, you can measure anywhere you want a density online, which is very important to, for especially making floating and sinking feed. You want to make sure your density is right. You don't want to make all the product for one day and then realize that my product density is off, then you have to rework it. This gives you real time after every 15 minutes, 15 seconds, give you the display, your density is off. Therefore, the dryer will talk about the extruder. Extruder operator will know my density is off, increase the pressure, increase the temperature, increase the moisture to adjust that, your density. Because you have to communicate real time. You don't want to make your product and then waste that one. That doesn't work that way because you want to make sure that they are working properly. And then, of course, you will see here, this one here, unit, can measure the bulk density, taper density, product moisture, product temperature, and image. Even it has camera on it, it will take the image of the pallet, that you is round or not. This camera set up there, and you can see that if the product appearance, person sitting on the computer room can see my image of the product pallet is smooth or not, if something broken, my knife is broken, something like that. You can measure that also coming up from there all the times. And of course, you can visual measure. Here's the image coming up, and the operator can see right there that see that if there's something is wrong. Therefore, basically, you have different kind of system. It gives you 0.5% moisture also variation. You can do it bulk density, also moisture measurement at the same time. Therefore, you don't want in that dryer to dry too much. What happens when you dry too much? Even 1% extra drying, you are going to lose a lot of money because you are selling a 10% moisture content pet food in the US, 9.5 for 10%, and you're drying 1% extra. You don't realize that drying 1% extra, you are 10 tons per hour. You calculate you're losing a 10 tons per hour, 1% extra per hour, per day, per shift, per week, per month. You're losing a lot of money. And then also 1% extra drying going to cost you a lot of steam injection, steam. Therefore, if you do this system within 6 months, it pay back because you are measuring exactly the same amount of moisture like you are making 9.5 guarantee, if 9.5, not 8%. Because 1% extra moisture, that means you're losing all your profit, you're losing 1% production, and you're losing it also a lot of energy there to do that one. If basically, inline moisture measurement, you can do it feed forward, backward dry control, sell more water, obtain more uniform. Therefore, you can have basically different place coming out from the dryer here, coming out from the coating after. You can measure all that moisture, what my moisture is going to be. Also, you can do it with that inline. You can see the fat absorption. You can see that one. Okay, this is approved. This is better fat absorption. This is not approved because there's not poor fat absorption. Therefore, basically, vision system can also detect you and give you alarm that it's not working properly, you need to change your vacuum, maybe change your system there, because you're not properly coating the particles and the fat will come out. Therefore, there's a lot of different things that are available to us to use in the system there to control our issues there. What's the future going to look like? You're going to have more flexibility required in the raw material. We wish we have more flexibility in the raw materials, that we can have a raw material which is grown exactly we need, which will process in the extruder. That doesn't work that way. We can have a contract growers. We give them the money to grow GMO, non-GMO crops. We have contractor field. We can have some contract field which grows specific variety of that, which will work much better in the extruder. We can have its growers to grow special rice for the extrusion. We can grow special wheat or from corn for the extruder, which work the best. And that's hopefully that. We're going to have more sophisticated product. And of course, extrusion is going to combine with other unit operation, like I mentioned that, and unique control system going to come up with that, and they're going to have very, very bright future in there that you're going to have that. With that, one again, last slide for the books there. I will be happy to answer any question you have it. My time is almost up before the next speaker comes in. And once again, thank you very much. I appreciate it. With that, if there's any question, I will be happy to answer. Thank you. Nobody asking any questions? Well, once again, thank you very much. And I think you have my emails. It's not like it's simple. It's, I think on each presentation I had it. And if you have any question, you can always email me with that one. I don't know if I have the first one there, email. You usually have email on every slide.
On the first, there it is. First page.
Yes. There is the email, mnriaz@tamu.edu. If you have a question, feel free to email to me. We also do a training program, short courses, which is 1 week long on extrusion, Aquafeed, pet food, and also human food at Texas A&M. Therefore, it's a 1 week long course where people can attend. It was before COVID, 100% in person. During the COVID, it was 100% virtual, but now it's a hybrid. Therefore, people from other countries who cannot travel, they can join us live, ask questions, and attend the live course. Of course, time difference is going to be in Philippines to USA, 13 hours. We will nighttime and daytime. But you can attend the course online, or if you want to travel, come over there. We have a lot of their activities. We do a lot of putting the 3D modules, bring them here, let you put machine together, work on it, put the screws together, and we do a lot of different kind of demonstrations. Some of the courses we go in the lab and work with the small extruder as well. Therefore, basically, any question, you can email me. We do 4 courses per year at Texas A&M, 1 week long. Aquafeed, the pet food, and also just regular feed, and that human food, snack food, and as well as protein, plant-based protein, and other pulses, all the extrusion of that. Therefore, any question, feel free to do back. And also, I still have, I think one person got the book. I have 1 book. If anybody is interested to get it, it's more than welcome, because it's very heavy, as mentioned. This is shipping is too much. I just brought 2 books with me. With that, thank you very much, and we have next.
Yes, so there was already a lot of information this morning, so I hope you could digest. Yeah, I will also add to that a little bit. I will give you basically just a short overview again on the whole process, and also introduce a little bit about Carl. So yeah, maybe first let's start with myself. So I'm Arne Heuer. I'm working for Amandus Carl. I'm now in the company for roughly 11 years, and I'm responsible for the sales, or also with the team together, responsible for the sales here in Asia, and of course also in Taiwan. We are working together here also with an agent for a long time, Agriweek. So we are also having a shared booth down in at the exhibition. 412. Okay, 412. So also make sure to come by and say hi. And also there, of course, we can kick off discussion and continue, of course, then further talks. And if you have any questions, surely also make sure to touch them, because as mentioned, they are well experienced and are well known here also in the Taiwan feed and food business. All right, so today my talk is the basics of pet food plants and the introduction of equipment and process. Or other way around, okay, never mind. So yeah, first off, let's kick off with a smart, quick introduction to Karl. So Amadeus Karl is a private-owned, family-owned company from Germany. We are part of the Karl Group, which is consisting of 6 machine manufacturers. We are all located in Germany and are all in the plant business or plant building business for different industries. For example, Amadeus Karl is mainly in the animal feed business, but also in the biomass business, for example, for wood pellets. Then we have Schule, they are in grain handling, so rice milling, oat milling for the cereals, for the breakfast. We have Neuhaus, they are in coffee bean handling, roasting. And then also the newest member is Riaz. They are in the oil extraction. So for oil seeds, they do the oil screw press to extract the oil from the seeds. As mentioned, we are all located in Germany, so our production is all made in Germany. But of course, today we ship worldwide, so we have customers all over the world. And with that, we have our partners, our offices around the world to supporting the local markets and the local needs. For technical support, for the supervision during commissioning, but of course also for after sales and also of course for talks when there are new projects, new problems, issues. Then of course we're always happy to be there to accommodate them and to work together to find a good solution for a good product. This is the headquarter in Germany with our offices and the workshops. Actually, Amadeus Karl is not only manufacturing, so not only taking care of the equipment, but we have also our own nutritionist in our Karl team, because for us it's important to not only sell the equipment, but to sell a process, to understand the process, so that we can make sure that the final customer and the end product also fits the demand, and in the end, of course, also has the benefits for the animals, for the where we produce the feed for. Basically, we also have a long history. Basically, Amadeus Karl is already roughly 145 years old today, but the pet food and extrusion basically is not that old yet. But we started already in 1980s. Back then it was mainly pelletizing. So Amadeus Karl is well known for the flat die pelleting mill, and this was the first, let's say, step how we introduced to this industry. And it was simply just pelletizing, and then over the years we saw that there was a higher demand and more demand to the process itself, so that we also then developed our own extrusion technology. Back then it was first in the 1990s with our expanders. They are also today broadly used in the animal feed for poultry, cattle feed, pig feed, but as more a gentle treatment compared to the extrusion process. So for pet food and also for Aquafeed, we needed to have a more sophisticated system, and so we continued the development of the expander into our first generation of extruder, where we had basically all-in-one machine to have conditioning, then the extrusion, and then this was the basic first process of pet and Aquafeed for Amadeus Karl. Later in the 2000s, we developed then a dedicated, rearranged our design for the extrusion plants to have it optimized, because over the years, of course, also we had developed more knowledge and gained more know-how together with our customers, and therefore applied the new learnings. And just recently, now in the early 2020s, we actually developed a new system, a new extruder, so that we have really, let's say, made our first steps and now had a redesign to have it more sophisticated, more specific design for our extrusion. But though we still have the old technology, and later on I will also come back to end my slides to show that we also still have today customers that actually use pelletizing for the pet food industry in Europe. But later for that. So let's have a look at the process flow sheet of the extrusion plant. So this is actually a plant for 9 tons pet food in Hungary. You may also later on, when you have the presentation, there is the YouTube link so that you can also then have a short video on the commissioning or the erection of this plant. So basically, what is the plant consisting of? We have the intake and storage proportioning with a weighing system in the beginning. Then we have some grinding and mixing stations here with a hammer mill. And then we have in the middle the extrusion and conditioning. And this basically is the heart of the plant. So this is everything else is basically working for this section. Afterwards, we have a drying system, and then here a fat coater, cooler, and then of course afterwards bagging, and depending on the final customer requirements, also some granulation. And this is basically the setup. As we already learned earlier with the speeches, there's a lot of things to consider for the process of extrusion, and a lot of things actually don't really taking place in the factory or in the extrusion plant itself, but really roughly, as he mentioned, 40% is the raw material, the formulation. So this is really where it comes, that you have to consider what materials you're using for and what is the final requirements of your product that you want to sell or that the customer requires in the end. Then we have 20% of conditioning, so this is the preparation of the raw materials. Then basically only 15% is the actual dye specification in the extrusion. And then the last 5% is then doing drying, cooling, coating. So you see there are a lot of different things, and I think also we learned earlier there are a lot of things you have to consider that has influence on the process and on the final product characteristics. Now coming back to the plant layout, here again you have a brief block diagram of such plant. Again, you have the main components, corn, soya, whatever, that you buy on the market. Again, depending on where you get it, how it is delivered to you, you have to consider different starch levels, which later on have an influence on the recipe and on the process. You have feeding, grinding, because as we already learned earlier, grinding is important to have the right particle size, to have a good treatment of the granules, of the particles, and the homogeneous structure and cooking inside. Then again, of course, you have mixing. You can add some minerals, vitamins, some other things which have not so much impact on the extrusion, but which in the end are of course important to have included in the feed. Then we have the conditioning, extrusion, and drying section, where you also can add additional oil and have all the different fresh materials that you add into the mix. And then afterwards, of course, yeah, you have the final product that is then ready for storage and bagging. Yeah, I will not go into all the details because I think we learned already a lot of this in the morning. But I also want to mention again and stress that grinding is quite important. Here we see that this rule of thumb for pet food, we say that you should be 89% smaller, 700 microns. And this also gives you then the fine structure of the raw material that will then also give you an even and good looking pellet. Otherwise you may still have the big chunks in the final kibble, which is also then the point where the final pet owner may discard your product because it does not look that nice. And also of course you may have more breakage because those big chunks tend to be the breakage points that create afterwards trouble and does not that look good looking in the bag afterwards. Yeah, and also of course with more homogeneous and fine grinding, you will also have a higher starch sterilization inside the product because you don't have those big chunks of corn inside, which may be not cooked fully through because it's just too big to be treated in a good way. So let's see here again the heart of the core process. It's the preconditioning and then the extrusion. Afterwards with drying, coating, and cooler. Again, as mentioned earlier here in the workshop, we saw that we have different kinds of feeding units. Again, here we see a weighing system. So this obviously is a gravimetric feeder system. So that is more sophisticated compared to the volume feeding and allows a little bit better changing of recipes and is more flexible, but of course comes with a little bit higher investment because you need the actual weighing. Here, Amandos Carl is using a double conditioning setup. So we want to go up to 95 degree. Of course, depending on recipe, maybe 80, 85 is also sophisticated. And we use this two different types of conditioner before our extrusion. And here we even have implemented another equalization screw after the conditioning. So we see here the green first is the mixing screws. You see the pedals marked as X, and then afterwards we have a screw that again homogenize the flow, that we don't have pulsating feed coming into the extruder and allowing a more homogeneous process. This is the setup that we normally use for our plants. We have a high-speed mixer, the so-called DLM. This is the first conditioning step. This is really to kick off the process and start the cooking. Roughly speaking, we will add 2/3 of the steam in this high-speed mixing. It allows the addition of high amount of liquids and has a short retention time. And it's really intense. You can see we have here really strong pedals that allow a high speed, a high RPM, and has roughly, I think, 30 seconds retention time, roughly speaking. And then after that, we go into the so-called retention conditioner, where we then want to keep the temperature for a certain level, a certain time, to allow good starch ionization and good cooking. Besides the starch, we also want to activate the proteins in there. So therefore, it needs more time and higher retention time. And also, as mentioned earlier by our first speaker, we want to make sure that we don't add steam in the first conditioner. Steam, yes, in the first conditioner. And in the second conditioner, we also add some steam to keep the temperature. And in the second conditioner, we also able to add oil. Because there we have the steam already added in the product. And then just at the outlet, we are able to add also some oil again. Again, you have to be careful not to add too much oil, because we learned it will reduce the friction in the extrusion and may increase your bulk density and may create problems in the process. But this, of course, all has to be discussed prior to setting up the plant, and together with your nutritionist, together with our nutritionist and our process engineers, we will then design, according to your requirements, according to your recipes, the right setup and the right parameters to be implemented there. Also here you can see with this setup we are looking to make sure that it's easy to clean. So we have big openings that you can open the flap and then you can access the pedals. Also here, depending on the situation of the pedals, the angle, you can improve or increase and decrease the conveying or the mixing. Depending on the angle, you have more forward movement, backwards movement, or just mixing. This you can all set up and depending on your requirements, set up in the machine. At the end of this conditioner, of the retention conditioner, we also have a special slide. I will show you on the next slide here. Because this actually allows to decrease and increase the flow rate through the extruder, through the conditioner into the extruder. With this slide, we have we are able to open it or close it, and depending on that, we have the material flowing back into the conditioner, allowing a longer retention time. So here you can see on the left-hand side, it's completely open. In the middle, it's half closed. And then here on the right side, it's completely closed or only allows a small overflow that allows, with a higher filling degree in the conditioner. And what this does is we increase the cooking and therefore the treatment intensity in the conditioning. What you can see here is two different or two graphs. First, I would like you to focus on the green graph. This is the temperature in the extruder. So you see here on the bottom line, we have the position of the slide, so how much is the slide closed. And the more we close the slide, the more retention time we have, so much more preconditioning. But you can see actually the temperature in the extruder does not really change. So the process in the energy input in the extruder basically is the same. But you see, because due to the higher or the closed position of the slide, we have a higher extrusion effect, expansion effect, because on the left-hand side, the pellet diameter will change. It will go up. So we have a higher expansion. So this way, you can influence, just by the slide in the preconditioning, the expansion effect and the extrusion in the extruder without actually changing any parameters inside the extruder, changing the die or changing the recipe. You can just online adjust the conditioning and therefore increase or decrease the cooking and the expansion effect. Talking about cooking, also this we learned earlier, the extruder alone is not a wonder machine. It has limits and we need to set up the raw materials correctly. So again, to give you a rule of thumb, those are the figures that we usually see with a degree of starch gelatinization. the raw material will come in with maybe 10 to 15% of cooked starch or gelatinized starch already. And then with the conditioner, we can increase this to 25-40% usually. And what we see is when we measure it, may vary depending on the raw material, we see first it'll go up quite quickly. So you start with cooking, and then usually after 80 to 100 seconds, you will reach the, let's say, highest possibility of starch gelatinization in the preconditioning. So of course you can then also keep cooking, but for the starch, this will not have a big influence afterwards. So usually we say, okay, for the retention conditioner, we need up to 100 seconds, but of course you can also go higher. I think in the market we see also sometimes 3-stage conditioning with up to 360 seconds, but this may then have other influences, maybe on proteins or other things that you may consider. Of course, this can all be then discussed and set up in your control system depending on the requirements. Yeah, this is actually what I meant. So there you mostly reach the level of starch cooking in the conditioning, and then afterwards you go into the extruder, where you then have the high energy input, and then the final, let's say, cooking. And then, as mentioned earlier also by Dr. Riaz, that in the dryer you will also add a few more percent, because of course you have the temperature from the extrusion coming out, and then also in the dryer have some heat level that will then also add a few more percentage, but this is really not the biggest amount. Okay, looking now at the extruder, let me introduce you to our machines. So this is now also a plant. You can see on the top the short-term conditioner, the retention conditioner, and then below the extruder with the outlet head with the knife motor on top, and then going with the pneumatic system through on the other side through the dryer, and then downstream to the rest of the process. So there you see the pet food, and how do we process it? So this is our original extruder design. You can maybe see, some of you know the expander machine. Basically, it's a quite similar design. So we have here the pedals inside. You can see it's interrupted flights. So we have different pedals, and together we also have here stop bowls inside that allow for higher kneading and mixing. Allow a very intensive treatment, and also because we have the interrupted flights here from the pedals, there's also some backflow of material so that we have a quite intensive treatment. And then at the outlet we have the die, and similar to the expander system, we have a hydraulic cone here, so the die actually is not sitting fixed on the outlet, but we can move it in and out. And especially when you have maybe some shutdowns of the plant, this is quite helpful because the die actually will release the pressure. So when you have a shutdown of the plant, the die can open up and release the pressure, so that it's way easier to clean and to start up again afterwards. Yes, so if I move, then you see the die will move into place, and you can then start the extrusion process. So yeah, quite simple machine. Also here we have the different pedals that you can start up, and that of course you can move around. So depending, you maybe start with compression, conditioning, compression 2, and then some cooking. You see also here we have core progressive pedals, so that they increase in the diameter, so that will also then increase the intensity of the treatment and of the conditioning before the expansion effect. And this is now our new design, our next generation extruder. So you can see in the inlet we still have some stop bowls, but in the back we then changed now the design to the separated barrels with again also different kinds of setups. So that we have jackets. As mentioned earlier, we are able to cool or heat, so that you have more process flexibility and more parameters to influence the extrusion inside your machine. Again here, we have different setups. We can move them around. We have, again, core progressive pedals to increase the compaction. We have draw-in pedals that are more used for conveying, so to move the product quickly forward and to create more pressure inside the barrel. We have single flight and double flight pedals with cuts or without cuts, so to have more backflow or to more pumping. And of course also here on the outside, the barrel, there are also different configurations with a screw design or straight design, which allow different flows of the material inside the extruder. So now you may ask, okay, now another confusion. Now it's not only Anritz, Wenger, and Karl. Now they have also different setups on their own, of course, and therefore we are of course glad to talk to you. But to give you a brief guideline, so as mentioned earlier, our first generation extruder is quite simple and it was developed from the expander system. So it is mainly used for pet food, for the economic quality, so for basic quality. And also the fish feed is mainly used for floating fish feed, but of course can also be for sinking fish feed, but it's not that flexible. With the new generation, the new system offers more flexibility, but it's also of course a little bit more complex. So therefore, it allows for better pressure build-up and more intensive treatment. And also you may be able to have more sophisticated shapes from the die and also smaller diameters. So with the new extruder, we also go down to up to 0.8 millimeter in diameter. So also smaller fish and feed may be possible. Here you can also see now a setup of different customers. This one is in Tunisia, if I'm not if I recall correctly, and the other one is in Egypt. And you can see the capacities are usually from 3 tons up to 10 tons, again, depending a little bit on the product that you produce, and of course also depending on the diameter and the energy input that you need to apply to the product. So, but for pet food, it can be actually up to 50 kWh per ton, but again, this depends on the treatment intensity you require for your product. And if you want to have a sinking, floating, pet food, and also how much oil you have in it, etc. So with the new extruder, we can make smaller diameters. You can see here some samples. So this one is perhaps 0.8 millimeter, and this is more like half centimeter. And we can also go up to 30 millimeters in diameter. It allows the quite equal shape. And also with the new system, you can see here on the left-hand side, easy die change and knife setup, so that you can just open up the extruder to access the tools inside the machine, and adjust or change depending on the wear and tear on the equipment. Yes, so that's that. Maybe I'm speeding a little bit. I'll try to slow down a little bit, not to confuse you too much. Of course, for the extrusion and especially for the pet food sector, you may also want to have a certain appearance of the product, so that the end consumer not only takes care of the nutritional value, but also wants to be happy to have a nice looking product, which maybe the animal, the dog, the cat does not really care about, but the end consumer wants to have a nice looking product. So of course you can also add some colors into the machine. That's usually done before the extrusion process inside the conditioner, so that you have different nozzles that not only add the water, other liquids or steam, but also have some coloring. And that's depending on your batch. You add some certain amount of, for example, red color, then maybe wait a few seconds, add another color, and then in the end it will mix through the extruder and you'll get the mixture of the different colors at the bagging. And of course, depending on the setup of the die, you may also have different die shapes. So earlier we mainly saw the holes, which gives you the round kibble, but you of course can also have sophisticated shapes in the form of fish, of triangles, bones, whatever you can think of. And of course also this can be adjusted depending on the selection of the correct die. Though of course you have to make sure that the compression ratio and the open die area still is correctly, but no worries, we'll help you with that. This of course also needs all to be controlled. So we have our ESA control system that takes control about the whole conditioning line and the extrusion line, including the dryer, and allows you to store the recipes. So you don't have to now put manually every time all the different setups or parameters for your line. Of course this can be stored, and then you can easily access this, reload it depending on the batch or the recipe that your customer has now ordered from you. And of course also there you can then change when you have a raw material change. You may also then adapt this stored information and update that. Today we also offer of course remote online service. So next to our technicians traveling around the world, our agents traveling to the customers, we also can offer a remote VPN connection to the system, so that we also don't always have to travel to your company or to your factory, but can also have a quick look from our headquarter into the operating system and give you a first advice, and maybe already can help you with some problems, and yeah, try to support you in all ways possible. Of course, also we have automated start and stop mode, so that you don't have to now adjust all the feeding manually, but just put on a button and then the system will start up automatically. And if there's some error, then it will also shut down. We have interlocking system, so that it's also safe to run. So this is the normal standard in today's factories usually around the world. Yeah, after that, usually we'll come with a belt dryer to dry down the fresh kibbles and to allow a safe storage. We learned earlier, roughly below 10% is the aim. Of course, you don't want to over dry, because then you spend energy and you lose weight in the bag afterwards that no one will pay you extra for usually. Yeah, after the belt dryer, we may also be able to add some oil or some fat to add extra energy into the kibbles. For low oil addition, which usually is like 3 to 10%, usually just a fat coating system is used, so some drum coating, which will just spray on some oil onto the kibble. And with a low oil addition, this will then just be absorbed by the kibble and is no problem. For higher oil addition, especially for the fish feed with up to 40-45%, you need some extra step, which is then usually done with vacuum infusion, so that you create some vacuum, and instead of putting the air back in, you put some oil back in when you go back to atmospheric pressure. So yeah, of course, depending on the requirements, you need to have different additives and different level of oil added. And yeah, especially if you have low oil addition, you also have to make sure that it goes mixed, because if you just spray a small amount, the small amount needs to be distributed, homogenized through the whole batch, so that you not only spray one drop of oil onto one kibble and then this has a lot of oil on it, but the other kibbles did not touch any of those. So therefore you need more intensive mixing then. Yeah, usually it's done with a batch, especially if you have the vacuum process, because you always need to have some vacuum sucked and then later on add it on, and this in a continuous process creates a lot of trouble to seal everything, so this is usually done via batch. Yes. So how does vacuum coating work? I'll just give you a brief overview. Usually, first step is that you create the vacuum, so you suck out the air, and then you create, let's say, open space in the pores of the kibble. Then you add the oil, and in the beginning, the oil will just put a layer outside of the kibble. So that's then when you add some of the air back in. So then, due to the applied pressure again, the oil is pushed into the kibble, and then in the end, you have much more liquid inside the kibble than you would otherwise could just by spraying from the outside. Actually, there's also another step that you can do, that you can even layer the coating. So for example, if you here not go back to atmosphere, so first you have the vacuum, you spray some oil, and then you don't go back to atmospheric pressure, but only add a little bit of air again, and then you do another step. So you just add again another liquid again, and then only go back to atmospheric pressure, so that you have in the end a double layer coating. So in the middle you have the first liquid, and then you add the second layer. So for example, this can be done to add some nice, delicious coating, so that the animal don't have in the first bite directly the internal liquid, but only the nice tasting and smell from the outside, which allows maybe for a higher feed rate. So traditionally, it is done by a twin mixer or this screw mixing with fast running mixing tools to allow a high movement of the kibbles, to allow a good mixing, and to allow the oil to distribute throughout the whole batch. But this creates a little bit problem, especially if you have dense, delicate kibble or big kibble, they tend to break. And because a lot of physical stress is applied, you may break and create fines and micro cracks, which will later on during transport create fines and a lot of dust in the bag, which is of course not desired and may be a sign of bad quality by the customer, which they will not appreciate. So therefore, Amandus Scar had developed a new system, the so-called gentle vacuum coater. So actually this is a special drum coater, and it is shown here. So again, we have the vacuum pump, the liquid nozzles, just as a normal system. But instead of having quick-moving mixing tools, we just have a big rotating drum that is first filled in. Then we go into the vacuum position, where we suck out the air, and then can add the liquids. And you see, due to the rotating of the drum, we have a gentle mixing, so the product is moved, but is not hit hard by any mixing tools. We add the liquids, again, depending on the recipe and requirements. And then after sufficient time, we can release the vacuum again, here with the vacuum pump, and then go back to atmospheric pressure, and then release the batch down to the cooler below. Yes, so that's the system. And now it should move the slide. So the purpose mainly was that we wanted to have a more gentle system to be able to implement the same system in the existing plants. So it should not be much bigger or more complex. It should just be able to put in have similar dimensions and increase the breakage and the micro cracks inside the kibbles. And also, of course, it is quite important to be accessible. So same as for the conditioners, we want to make sure that you can clean it after some batch, or when you change your recipe, you may want to make sure that you don't have any cross-contamination, so that you can able to easily clean that. Again, showing you here the different positions. So we have the filling from the top, then we have the working position where we suck the vacuum and add the oil, and then the emptying position to the cooler. And then you can also rotate the drum to the back, where you then can easily access it and use water to spray into it, clean it, and then dump the water below. Besides, because we don't have any high-speed mixing tools, we also could reduce the energy input or the motor drive that is required. So actually we only have a 15 kW motor to rotate the drum, and a 4 kW drive to rotate to swivel the drum from one position to another. Compared to other systems where you may have 60 kW installed on the fast mixing coaters. Of course, okay, now I talk about gentle, so what does that mean? We did here some trials with the institute in Norway and compared the coating, our coater, or the new coater, the gentle vacuum coater, to the twin shaft mixer. And we tested this for different fat additions. So basically it means for different mixing times. And when you compare the results, you see that we have, depending on the mixing, roughly 7% less fines produced, or with the lowest fine difference, roughly 1.4% difference. And when you now calculate this maybe as a rework, because when you reprocess the product, one has a rule of thumb that processing 1 ton of feed or reprocessing 1 ton of feed may cost €30 per ton. And now when you think of you have to reprocess 7% of fines, this can add up quickly to more than €150,000. And so therefore, if you can save on dust and fines, you can save on rework, which on one hand is better for your production cost, but also lowers, of course, in the end, or increase your product quality. So after coating, you will basically have the final product, which is still warm, and then you have a cooler. This, of course, can be a current flow cooler, quite commonly used, quite easy, or of course also similar to a belt dryer, you can also have a belt cooler, which is a little bit more energy efficient usually, but of course needs more space and maybe also more investment cost. And typically the counterflow cooler is the choice that people take. And then before bagging, before storage, you usually also have a sifter to make sure that you only have the nice full pellets there, so you don't end up with a lot of fines in the bags at the customer. And then finally you have your product that can be marketed and sold to the end customer. As mentioned earlier, Amandus Karl is well known for the flat die pelleting mills. So I also just want to give you a brief introduction to the pellet mill. So basically what we have a pelleting chamber with rotating rollers onto a die. So not with an extrusion die, you have the die set up vertically and push the material with a screw against it. Here we have the roller rolling onto the die, pushing the material from the top through the die holes and then into the knives underneath, and then we get the pellets. Here actually we have pellet presses for cold and warm pelleting. So with the extruder you have high energy input, high temperature, and with the pelletizer you have less of this treatment. We usually have this in Europe with capacities of only like half a ton, so very small capacities, but also up to 10 tons. And in different countries, I know in Netherlands, in the UK, so in Europe it's used in different areas for especially the pet food. So, and we also here have another animation where you can see the principle of the pelletizer, and also for the pelletizer, similar to the die of the extruder, you can also have different shapes. They might not be this sophisticated compared to the extruder because there you have more of the starch neutralization happening. You have more possibility to shape actually the extrusion process. Here we have a little bit more simple shapes, but can also have for different animals and different characteristics, different shapes formed in the die. And then just let me check if I missed anything important. Otherwise, this would bring me to the end of my presentation. And I, again, thank you for your attention. And hope you enjoyed the workshop. And if there are any questions, feel free to ask. Or later on, come to our booth, 412, and or just connect to us. And then we're happy to go into discussion with you.
Thank you very much.
Thank you much.
The last one was a question answer session, and if there's any question, you have it. And your question. Also, please make sure you don't leave. We're going to have a group photo here. That will be in either the Petfood magazine or Aquafeed magazine. Therefore, we will take group photo here. That will be published in the magazine. Therefore, you don't want to leave that. Last question.
I can speak to that. You mentioned in one of the slides about the percentage of starch gelatinization in these stages, and it only went up to 98%. Is it never 100% cooked then? I'm not a technical person, so I could be.
So I think it's just, so as mentioned earlier by Dr. Riaz, usually it only goes to 90%. This is the level that you want to reach. So 98% I think is already quite high, and otherwise you may overtreat it. But I was sure he might have a little bit more economic.
Well, this is a lab result.